suggesting as we go to the settings section to change out what the inner audio is coming from.
Social creativity games, and so I'm delighted because I'm doing two projects in either direction. So thank you very much for merging with my life easier.
I'm Riley Eichner. I'm a Georgia Tech student. I work under Russian Gold. And I was doing a project in cognitive science that was supposed to be unrelated to cognitive creativity. But then we found some links anyway.
I'm Kate Compton. I'm at Seaside Place with my influence. Yeah, I do casual creators.
Hi, I'm Sven. I'm from the UK, Swiss Standard. I work with Simon. Simon is in the area of computational creativity, but I'm mainly interested basically I design for games for students.
Hi, my name is April, and I also am from UCSC, Kate, under Michael Matthias, and I worked in games and AI for game characters, and then I moved into computational crafts and using AI for personal crafts.
Hi, I'm Brent Siri. I'm a digital media master student here at Georgia Tech, and my project is actually coming out of Dr. Brent Dr. Nicholas's Project Studio.
My name is Chris McBride. I'm also a digital media master student here at Georgia Tech. I worked on the same project of data awareness.
and some of the work I'm doing is also on creativity. So not sure about that gap there, but really just what you guys are doing.
Hi, my name is Christian Rugesberger. I'm a third-year PhD at Goldsmiths Lab. I work together with Simon College. And my big interest in is how we can make artificial systems to be creative and right. And I'm looking into how we can achieve this with works of intrinsic motivation and with applications in video games. So I'm interested, so I'm using works of intrinsic motivation to do game AI and procedural continuation, which is more general and robots.
I'm Simon Nicola from University of Helsinki, working under Untitled. My working title in PhD thesis is focusing on creativity and systems. And now I'm working also going to more self-adaptivity and systems. And there's around the university there.
Hello, I'm Untitled Chapter from the University of my main research is on metaphors and creativity. How to have
Did anyone arrive after we started all that, but didn't have a chance to get up? Do you want to just say?
Hi, Mark Riddell, work here at Georgia Tech, literally there. So I work on human-centered AI, which involves all forms of humans working with AI systems, AI humans, and computational creativity, especially in storytelling.
You know, the idea behind workshop is that it's not a mini conference, it's more like a workshop. And so the way we've organized it into these sessions is there'll be brief presentations by each person with minimal questions, if any, at the end of it. And then we'll have the people giving the presentations come up here and sit in a panel like group and think about the questions that you ask, not just clarification, but how to synthesize or how to share ideas across the presentations that you've seen. Even if it feels like they're very disparate and not really connected, humans are awesome at making patterns and connections. That's your role today as the people here in the workshop, not to just listen and hear what other people have to say, but how do we put all this together? It's one of the reasons for running a workshop on this topic is to create community around it and to see where we have things in common and where we can learn from each other, not just to hear what each of us is doing, listening, and going. Okay, so the people who are listening and watching are as much participants as the people making the presentations. Now we've been significantly challenged because our presentation equipment is not working. So the presentations can't be the highlight. They've got to be sort of the starting point. So as you come up to give your presentation, you'll notice that the best we can do is give you a projection where the screen is too small. What you're going to see isn't the whole projection. Is that correct? You're not going to see all of it. It's not a matter of changing the resolution.
This projector going to
We're bringing another one.
Oh yeah. We've got like eight projectors up there. We're gonna find one that fits.
So what do you recommend? Do we start and someone do
I think starting and just we'll get set up as we go.
Okay.
Yeah.
Okay, wait on it. Okay, so
We could also have like somebody Google Hangout over there and do a screen share.
so the first session has defining interactions for co-creative task creation. And after that is the computational challenges of co-creation. And then the people who are sitting over there, no way they're going to see anything unless you actually stand up, move over here, and hide and see. So I recommend you do that all the time.
And why were you slow? And well, another is not.
You're fine. Yeah.
If you're back in space and you project,
Yeah, it's fine. As long as you're not this high.
That toward mutual theory of mind is a foundation for calculation. Just giving that presentation.
Yes.
Oops.
Alright, I'm Bobby Edgar, as I said before, and I'm going to learn that this is going to seem a little off topic for a while, but this wasn't intended to be a I was in a class on intro to cognitive science, of which she was the teacher, my professor, and we were supposed to build something that was a cognitive model. That was pretty much a deep creative situation. Go do something like TV. It happened that it's kind of one of my group mates specializes in CS education. And she was studying someone's master's thesis at the time where they had compiled information on the kinds of things that students who are trying to learn to write programming programs don't understand. Where do they mess up? And specifically, they spend a lot of time examining the summary statement. And as simple as it may seem to a room full of computer scientists, that if you say X equals 5, it has a different meaning. To someone who's just learning the program, that keeps surprising. So what we were initially studying was how do people misunderstand these things, and kind of an interesting bit of play that, well, what is it like to make a cognitive model of somebody who's wrong? Instead of trying to build a cognitive model that sort of works properly in the sense that it actually gives you accurate results. And as it worked, we came across the notion of the notional machine, which is how people in CSA think about what a person has in their mind when they're saying, okay, I'm typing this, now what's going to happen when the computer runs it? What does the computer know? And what does it do with that knowledge? At the same time, since we were studying cognitive science, we were coming across the notion of theory of mind, which is essentially the same thing for when you're thinking about other humans. What does this other person know, and what are they going to do with that information? And so we started to compare the two as we did the project and said, well, my theory of mind for a person isn't really that different from my thinking of an emotional machine. It's just two slightly different twists on the same concept that happens to have evolved in different fields. So I touched on this, but we focused on assignment statements because they're so simple. I'm sure all of you have done a lot of work where it's incredibly difficult to model exactly what's happening because there are too many features. So we broke it down to this tiny thing where someone had already spent years figuring out just that much, and were able to take advantage of their work and actually implement it. This is a really straightforward example of what kind of code we're talking about. This is a correct run, but it shows that if a programmer running this code, it would say CA, SAM, create a appropriate variable, so we equals gap, and then copy the string. And this shows some of the misconceptions that we were implementing, where you can see, for example, number 4 is correct, but number 6 copies it in the wrong, copies it over and then deletes it. Number 8 copies it in the wrong direction, and that's the kind of mistakes we can make. The prototype actually can take in arbitrary chunks of code that are correct. We didn't play around with error correction. And then for the diagnosis node, the basic prototype says, okay, I saw these variables. What do you think those variables are by the end? And once you tell it what you think they are, you can take that and model every misconception it understands and say, oh, what you just told me matches this. And from there, they'll tell a way of visualizing what the difference would be to every state. And on this version of the actual program, you can click through each line of code and compare position by position so that you can see when things started to converge and actually exactly what was there. So ultimately, what we came around to was thinking about how this could turn into a kind of collaboration with the computer. In one sense, it's building a collaborative understanding of communication. It's not just that you're telling the computer something and the computer says, I don't know what you're talking about. Give us a way. I think you were trying to do this, and here's how that was different from what I thought you were trying to do. So we were looking into the research on what happens with collaboration in humans. And we found that there is some research that shows that if you put a group of people together, like say we're all doing a workshop, their collective intelligence, their ability to achieve a task, depends more on their understanding of each other than it does on their individual intelligence. So a group of intelligent geniuses who can't work together at all is not as effective as a group of more average people who are able to understand each other clearly and build collaborative communication. And we even found some research where someone had taken that same idea, and you would think it would just be a matter of being able to see people, being able to make eye contact, taking advantage of body language and all of that. But really, they had humans only communicate through text. And they still have the same effect, that your ability to form an effective theory of mind in a human predicts your ability to work in groups together. I thought that was a really interesting thing for artificial intelligence and something we should continue working on, but we haven't figured out how yet. Because if you have it working in that purely text interface, that means that theory of mind matters a lot, even if you're interacting in the same way that other people. If we take a fairly good AI and have it talk to you through text, your ability to form theory of mind with that computer is going to matter for your ability to collaborate with it, probably. And so we're still figuring out how exactly we're going to build out systems that can test that. And that's not there. Thank you.
Before we move on, are there any questions or clarifications? Remember, comments about the work you mentioned.
All right, so I wanted to my name is Ana Shamoa. I'm a postdoctoral fellow here at Georgia Tech, and we present this position paper called Computational Challenges of Creation in Collaborative Music-like Coding. And so this is a collaborative work with Gerard Roman, Pratik Shah, Jason Freeman, and Ryan Magerko. And so first, I would like to ask whether are you familiar with this term music-like coding? Who's familiar with this term? So this very computerized live coding is an improvisational music practice where you're supposed to code in real time and project your screens. Then there's collaborative music live coding, which is more than one live coder performing together. So here's a listening room. So as you can see, well, you can't see, but here you can see the screen. You project what you are coding. And here there are two performances that are online, and we are sharing the screen. We have two laptops, and each one is coding half of the screen. So that would be an example of collaborative music-like coding. Now, this position paper looks into how research is done computer sketch, which is how many of you are familiar with sketch? So sketch is a platform developed here at Georgia Tech for learning programming language by making music. It's online, it's a browser-based platform. And so it follows the digital audio workstation interface. You have several kits that you can load, and then you code in the code editor and create a song. And so there is this iteration, you run the code, and then it renders at the top as a digital audio workstation. You do changes in the code, run the code again, renders it again, and you can do it in a live coding friendly way. So we've done some research looking at EarSketch as a tool that supports collaborative live coding. And as you can see at the bottom, we've explored two kind of approaches. One is simultaneous editing, like Google Docs, where different users are sharing the same script with their own laptops. And the other approach is turn-taking. I can show you a video again. It's basically inspired by the pair programming approach in the industry, but applied to music. And so we've explored like this turn-taking where there is a navigator and a driver, or two navigators and driver. This is research that we really presented at the this year. And so there is a chat on the right. The live coders can talk together, make decisions while they are doing music. Right, so from this research, and then smaller. See, we created like this framework thinking from this research we've done. What if we added a virtual agent into play, and thinking on two scenarios that EarSketch maybe is designed for education, but also for performance. So we would like to think about what if we had a virtual agent both in education but also in the performance. How different would it be helpful? And so I will walk you through these 4 cases. Okay. So we will start with education scenario. And so on the left we have the human interaction, on the right human relation interaction. So in a human interaction, we've identified that students collaborate together, and so in terms of computational tools, it will be important to support this collaboration and this social conversation. So tools like a chat is interesting and useful, or the possibility of sharing the script, or also allowing different ways of accessing the script. And also there are some trade-offs we need to make. So this can be an interactive experience for the students, but it can be very chaotic as well. So it's interesting to question ourselves to what extent this collaboration, there needs to be egalitarian roles or non-egalitarian roles, and also whether students need individual spaces or shall they all be sharing all of their actions. Well, if we move to the virtual agent bot, we identified that there are two kinds of bots that can be useful. One is the instant messaging bot. We can tell you, give you advice, tell you things that you can do or decisions to make. But there can also be the netcoder bot who helps you in showing other ways of coding and also maybe saving you some mechanical work. We also think that a human-like chatbot can be more interesting than just a recommendation system bot. Basically because it can provide a more qualitative experience to the collaboration. Now moving to the performance, you have the same comparison between human-human performance interaction and human virtual agent interaction. So from our previous research, previous work, there are pros and cons in the two approaches we've studied, like simultaneous editing versus turn taking. The first one can be maybe too chaotic again and code grows exponentially. Whereas the second one, it's clearer for the audience to see what the two lecturers or more are doing, but then it can be very, very slow. And another question is as well, to what extent we need to provide individual spaces to the lecturers, and how would that look like? Now, if we add a virtual agent to a play, we identified two interesting bots. One can be a performance bot who helps the performers to develop their skills in improvisation, but also in the rehearsal space, this bot can be interesting too. Say if the musicians cannot come, you can collaborate or still rehearse with your rehearsal bot, and she can learn from you. And also another model we've identified, typically there's not much research on Java or human virtual agent in collaborative music making and recording. One notable example is Lolbot, developed by Professor Pingley and others. And so, but typically the approach is the follower agent who follows what the performers are doing. Now, we think that also having a more own style agent can be interesting too. So, this research in the paper, we discussed how creativity can be useful as well. And so we identified designing and evaluating these systems applied into creation theory can be very interesting. And so we identified two potential connections. One would be participatory sense making applied to this algorithmic thinking that happens when you are live coding and you project your code. This is kind of an algorithmic thinking, and then if you're collaborating with more than one live coder, you can kind of apply this participatory sense making and understand what's going on from the projection. Then also the regulation of interaction suits very well in these turn-taking timings that happen in their own course. And we also identified a new interesting area, which is virtual agent interaction only. But then the question is how meaningful that can be for education and performance. So quickly as future work, we think that it can be interesting to provide or explore this bot that is both live coder but also a chatting peer. And we think that machine learning algorithms can help us to shape this bot that can be more than an imitator. And applying co-creation theory can help us also to understand and design better these kind of systems. And then these suggestions from the community are very welcome. Thank you.
The next presentation is going to be puppets. Are you ready to go? You can tell me. Yeah, I don't know.
And while she's setting up, are there any questions or clarification? And then I'm ready.
Yeah, it's
The screen.
Well, once this one moves more, yeah. What's the question? So it's not. Okay, let's do this.
My name is Jessica Fitzgerald. I'm a student working with Dr. Shoko, Dr. Adrian Thomas. I'm talking about our work on defining interactions for code-free task transfer. In order to situate the work, our work is at the intersection of cognitive systems and robots that interact with people. Specifically, what that does is it forces us to ground these cognitive systems in robotic action and perception. And the way in which we do that is through human-robot interaction. The goal here is to develop systems for high-level cognition agents which operate in low-level action, perception, and interaction in the physical world. The specific domain that we're working is this, a robot that interacts with a human teacher in order to learn tasks. Here's an example of what that looks like. So here I'm just guiding the robot's hands in order to teach it a task rather than program a task. Here I'm just teaching it discrete tasks from one role to another. And while I give it this demonstration, the robot is recording the position of each one of its joints through each moment in time in order to create a model of this action. So while the system of having a robot learn from these sorts of demonstrations is well developed, we're addressing a related problem, and that is how do we get a robot to reuse what it's learned from the demonstration? So let's say here at the left, this is the environment in which the robot learns to complete this task. And by environment, we mean the objects that are used, the configurations of those objects, and so on. And we refer to that as the source environment. And at a later time, we might want the robot to repeat what it's learned in an environment such as the one at the right. So here, objects have been moved around a little bit. We have the red bowl, because of the blue bowl, moved around. We want the robot to be able to take what it's learned in the source environment and reuse it in this target environment. The goal of which is an action that looks something like this. We want the robot to repeat what it's learned using these new objects. The problem that we're addressing here then is that of transfer. So at the top we have the beginning and end state of a scooping task that the robot learns in the source environment. And here at the bottom we have the initial configuration of a target environment. We want the robot to reproduce some similar action that produces a similar goal state in this new environment. So while learning is a well-addressed problem, transfer from a single demonstration is not as well addressed. And throughout this presentation, I'll talk about co-creative methods that we've explored for performing this transfer problem. The way in which we do this is by situating the task transfer in human interaction. So while the human teacher is already there providing a demonstration, we want to see if we can continue to leverage that interaction with the human teacher in order to perform transfer, but also without requiring the teacher to give an entirely new demonstration of the task. In some of our previous work, we've looked at how this might occur in a mapping problem. So how does the robot understand which objects that it's familiar with map to new objects in its environment? And how we've done that is by separating the interaction into two stages. That of demonstration. So here we have a teacher demonstrating how the robot should stack these cups. And then in the target environment, we've given the robot a new set of cups. Here they just differ by their color. And the teacher provides the robot with hints. These hints are just guided interactions in the target environment, where the teacher either indicates the next object for the robot to use, or where it should place the object that it's already holding. And this is in response to the robot asking questions like, what do I use next? Or where does this go? What we found is that by providing these mapping hints, the robot is able to ask for help during the first 1 to 3 steps of the task. And then after receiving those initial hints, it can complete the rest of the task autonomously by inferring information from these hints. And that interaction looks like this. Here the teacher is just handing the robot the next object it should use. And then the robot asks where should this go, and the teacher can indicate that it just stacks it on top of the other cups. And from this interaction, the robot can record something about which objects it should use next, and use that information to infer something about the rest of the task. So while this is clearly a collaborative action that's going on here, it doesn't yet seem creative. In the main talk I'll be giving on Thursday, I talk about this a little bit more, but we've looked at some criteria for what makes a robot creative in this context. And the 3 that we focused on are that of autonomy. So the robot needs to have some amount of agency or autonomy, in that it might still interact with the human teacher, but it needs to be doing some actions on its own. We've also looked at novelty, meaning that the actions that the robot performs need to be at least novel to itself. So some sort of an action that it hasn't performed or learned before. Or use some sort of a creative reasoning method, which might include combining multiple tasks that the robot has learned. So in order to address this question of novelty specifically, I'll talk more about the types of problems that the robot might need to solve through transfer. We've looked at how we can categorize these transfer problems according to a spectrum of similarity. So here at the left, we have an overhead view of an environment where the robot might learn the scooping task. And at the right, I'll show a few examples of where the robot might be expected to repeat this task later. So here, this is the simplest example of a transfer that we can think of. The robot recreates the task in the exact same configuration which it learned. And this isn't a practical example of transfer, but it just shows this is one end of that problem spectrum. In order to address a problem in this category, the robot can take its entire representation that it's learned before, and without changing that representation, use it to recreate the action in the new environment. We can imagine a slightly more dissimilar problem here, where the same objects are used in this target environment, but they've been moved around. So while the pasta bowl is the same, the bread bowl is the same, they've just been shifted, so the robot needs to slightly adjust its representation of the task. So in order to address problems in this category, the robot can reuse most of its representation, but one aspect of it, which is the object features that were previously recorded, and that includes locations of objects, that needs to be replaced with the object locations that are perceived in this target environment. Another category is that objects have been moved around and replaced. So now the red hole is replaced with the black hole. There's some other objects that are irrelevant to the task. And so here, in order to address this category of problems, the robot needs an object mapping that tells it which objects in the source environment correspond to which objects in the target environment. More difficult problem, objects are moved around, replaced, and the scoop that the robot is using is different. So it's hard to see on this projector. The scoop that is shown up here in environment 4 is twice the size of the one that the robot learned to use originally. And what this does is it introduces a new constraint to the task. So if the robot were to try repeating the task without adjusting the size of the scoop, it would hit the table, it would knock things over, and basically would not be able to reproduce the task. So in order to address problems of this sort, the robot needs what we refer to as a new parameterization function. And that's just a function that tells us how the endpoint of each step in the task should relate to objects that it's using. So how high above the table does it need to keep its hand? How close to the possible does it need to move, and so on. Another category is one that requires new skill models. So here we solve a similar task with scooping pasta. Now there's a lid on the pasta pot, which the robot has no idea how to use. It's never learned to pick this up. And so there's another step that's needed where the robot needs to learn how to pick up the lid of the pasta bowl before completing the task. And here the robot needs this additional step to be taught to it. So you can imagine that these problems become more and more difficult over time until we get to a transfer problem that's so dissimilar that the robot can't address it in transfer. Here we have a task that doesn't even involve scooping because there's nothing to be scooped here. So what we've done is related this task similarity to the number of elements that the robot can reuse from the original demonstration. We categorize this into problems that do require creativity to solve and those which don't. And here how we look at this is, in terms of novelty, a creative problem is one in which a novel action is required for the robot to be able to address that problem. So we looked at these two categories as creative task transfer problems because the robot's motion must change to account for these new constraints in a way that the robot has not learned how to do. Whereas for these easier problems of transfer, the robot's motion does not change considerably. It just needs to parameterize it based off of objects, but it doesn't need to learn any new actions. How we've looked at addressing these sorts of problems is by still maximizing the robot's autonomy, but by having it interact with the human teacher in order to gain the new information needed to solve these problems. How we do this is have the robot continue to step through each of the steps of the task and ask for help as needed. In order to do that, the robot needs to identify what aspects of its representation can be reused and what aspects it needs to have replaced via interaction with the human teacher. So this first category of problem, what that would look like is have the robot evaluate for each step of the task, whether it will be successful in that step, and if not, request the teacher to reposition its gripper or its end effector in order to manipulate the new object that hasn't been used before. What that might look like is this, where instead of having the teacher give a new demonstration of the task, the teacher just needs to move the robot's gripper in order to handle the new object that it's seeing. And from this point, the robot would just record the new offset between its gripper and the object that it's using. In the next category of problems, such as where the robot needs to learn a new step in the task, for example, lifting up the lid off the pasta pot, the robot needs to do something additional, which is either request a redemonstration of just that next step, so ask the teacher to teach it how to remove the lid off the bowl, or identify another instance in memory where the robot has used a similar object but maybe in the context of a different task, and then combine this knowledge in order to address this problem. In which case the teacher would either verify or correct the robot's actions. And so that interaction would look something like this, where the teacher is actually redemonstrating just one step of the task, but not the entire task. In doing so, we're focusing on how the robot can select specific interactions or ask for specific assistance in order to both maximize its autonomy. It doesn't need to be re-demonstrated the entire task, just that one step, while also leveraging the human teacher's knowledge of the task and how to give the robot that missing information. In our future work, we're looking at the problem of how the robot should select these different types of interaction based off of the transfer problem that it's trying to solve. This is a challenge for us because the robot needs both enough information in order to address the problem, but while also maximizing its autonomy. So I'd love to talk about this more during the break.
Next one is and while he's setting up everything. So we have two more, and the break starts in 10 minutes, and everybody's prepared somewhat near 10 minutes presentation. So we can either let these two go, everybody grab a cup of coffee and have a panel at the last half of the break, or we can stop at 10:15 and have the last half of the break. Any suggestions? I prefer to have the panel and let's just break at 10:15. Is that okay? Otherwise, there's a discussion.
I only have media input, and this is HMI, so I'm not to make this run. So can we?
We'll have the research tool to quantify interaction dynamics through time.
So before that, anyone using USDC, that's too modern to this ancient machine. So just find another machine that works with a VGA HDMI. That should work.
You have those down here.
Just right?
No, this is you use the USDC. This is the mini display.
Oh, then I'll look at this. And you're the next presentation. Okay. So who's presenting the research tool to quantify interaction dynamics through time? Oh, is that next speaker? And is there no one here? It wasn't followed.
I thought it was
You're not presenting. Okay, let's say it is.
That does say it this time, however, maybe we should. This is funny.
Well, I suggest, since we only have 10 minutes, why don't we put the making puppets in the next session? Okay? And why don't we bring up all the authors who presented so far? Turn the lights on and have 10 minutes or so panel, and then during the break we'll talk to the powers that be about how we
That's what we're, wait, didn't something come from my life?
No.
Okay, we've got.
Is that the only kind of thing? Okay, so the co-creative task transfer. That was you. Yeah. And then the theory of mind, and then the collaborative music and coding. Okay.
Okay, this is not.
I wanted to help get this panel going just by trying to bring up what I thought were the main points here. So I found the designing interactions for co-creative task transfer. One of the things in the theory of mind and then the collaborative music coding. One of the things that we're struggling with when we look at co-creation and co-creativity is how we take this idea of collaboration and working together with humans, collaborating with humans and machines, and transfer all of the research and work that we've done when it's been out from tasks into something that would be possibly I think that's a jump. Yes. And there was one slide there, it's one of your slides that said, what do you mean by creativity? How do we characterize exactly? And there were three things: autonomous and novelty, and the third one was creative reasoning. And I thought that was a really good start for trying to think through what do we even mean by creativity, and without diverting the entire discussion there to what is creativity. One way to preface whatever content or concept you want to use in the context of this, so you just say what aspect of creativity you think about. We would give it to you next, because we only have 7 minutes to go. So we're going to do a panel discussion now. So I thought what we could do today is the things that we heard were theory of mind. That's a really interesting and very human construct. The theory of mind basically is when someone is able to understand at some level what the other person might be doing. And multi-agent systems have tried to model that for years and years. How do I build a belief system of my own? And how do I build a belief system of what I think you believe? And that's basically what does that have to do with creativity? And then the other idea is an analogy and text. So I'll leave it open now. Whenever this is where you guys are the focus of the workshop. What is it that you heard that you thought was relevant to creativity? How can the work that they can do influence that?
Basically, just want to make a remark on the theory of mind talk. I thought it was very interesting. I think it's very thought to take that into consideration. We talked about co-creativity. I was wondering, just in case, if you still need some biological foundations or evolutionary foundations. Just came across a blog post from a archivist that makes quite a compelling argument why the theory of mind or a model of the cognitive dynamics of other agents is not only important for us as people, but also for any organism in general. And relates that to this free energy principle. So I thought it might be interesting, just in case we need some more foundations.
Do you think theory of mind is an essential or useful aspect of I just wonder if it's good to get it wrong. You know, if you don't have, or you have a false theory of mind, you might come up with something wrong. It seems to me not music system. A person can but that doesn't seem specific to me theory of mind. Well, I don't think there's one answer, but I think everybody's good.
So I would argue that basically any corporate system necessarily has a theory of mind because it assumes something about what kind of and what kind of people we want. It assumes something about what kind of reason we can itself and tries to reason or engagement tries to provide for you. So I think any computational corporate system that has been basically we don't usually make it explicit. And I think one very good question is whether we should have a personalized view of mind, knowing not what we want in general, but what this particular filter we want. But the big problem with that is that we almost never have any. Yes, that's what I think. Okay, so we just break into misunderstood each other.
good collaboration requires that both sides are communicating and understand what their expectations are. Yeah. And humans can collaborate more effectively with humans if they approach it that way, rather than
So when we studied improv theater, only a few years ago, this was one of the big findings that we came out, was the notion of building shared mental models. And I think that the more improvisational the setting in general, the more of that notion of creating a shared understanding in real time. And that's something I agree is a good metaphor for talking about human collaboration as well as human computer interaction. But it's all about, I think, how fixed that knowledge setting is versus how open-ended it is. And especially when we talk about pure creativity, it feels like we're also sneaking in at least middling to high improvisation kind of within this interaction.
You said shared mental models. When I think of what a shared mental model is, it means our common understanding about what's happening in improv, or our common representation if it's a piece of artwork. When I think about theory of mind, I think about I have my understanding, and I can think about what your understanding is that's not mine.
Yeah, I mean, one is a precursor to the other. I mean, so you can't have a shared mental model without treating the other person as a cognitive.
And I think there's three things.
Yeah.
There's yours and ours are shared.
Yeah.
I just wanted to go back to your point. You just said, do we want like a perfect theory of mind of a person? I think you put a good point in, because I've just been before this conference, I've been at a workshop on serendipity, and one of the people actually put forward some experiments where he counted serendipity in search and information retrieval, actually just because his systems had a lot of flaws and a lot of shoddiness in there. Right? So I would expect that we get more creative encounters if we do not have an accurate model of another agent's minds. But also, I think we also don't have to worry about that too much, because we are racially bounded agents. Then again, we should probably raise these boundaries in information processing when we build these models, and probably try to represent these in our modeling processes as well.
Happy accidents are absolutely part of the process.
I think there's a whole theory of creativity that is, Margaret Loeb talked about it in her book, that you make mistakes. When you reflect on the mistake you just made, you see its usefulness, and it becomes something interesting and novel because you didn't expect it.
Yeah.
So I think, I don't know whether flaws and.
You're talking about socially though, right?
Yeah, let me just try to make an example here. Like I collaborated on a paper a while ago, and I think
person, you need to sort of not only understand the agent, but understand the programmer. I think that makes
In
it
terms of like the encoded ethics involved, or?
well, yeah, the ethics, the mental model that's created the system. I mean, each of those are so different, and to sit down and expect right away, it's going to have a certain way. I wouldn't know how many one of those three things are going to take.
It's about a combination of different meaning-making techniques, I would say. And then the question about embodiment and ownership through embodiment. What does it mean? This is where we end up at the end of the talk, hopefully. The whole work is a collaboration with the Center for Contemporary Arts. If you are new in town and have never been to the Center for Contemporary Arts, please go there. It's about 3 miles as the profiles, and we have Skeksis and Opera and Muppets and Miss Piggy. It's amazing. And they're great people to work with. Good. The project that we're doing is about making puppets. So when you go to the Center for Contemporary Arts, that's a show that we did in 2016 called Of McDonald's Farm. So you go to one of the family shows, and at the end of the family show, you and the kiddie go up into one of the workshops and you start making little puppets. It's like the ones you see on your left. This is literally up in their workshop at the Center for Contemporary Arts. So they build little puppets related to the topic that the show was about. So when we saw this, we realized we could use this for advancing it from STEM learning, which is what the grant that we're working on is about. So we're trying to teach people making puppets. And as they make puppets, they embed circuits, very basic circuits in the puppets. And the idea is that we teach folks that they are students, middle school, early middle school students, right? These are middle school students, the idea that electrical engineering or basic circuit making and mechanical engineering can use of a puppet, which can be, by the way, extremely elaborate device. It's very closely related, and you don't have to be worried about one and the other. It's kind of in the pure sense of STEM learning approach. So these are some of the designs that we come up with. And that's kind of as complicated, computation-wise as it gets. A single circuit, battery, sometimes with 2 circuits, both for example there. Some of these different materials, conductive thread, conductive copper tape. But it's very basic materials, both pins, paper, LEDs, pipe cleaners, the stuff that you find in classroom. And these are designs that we make, and we make all projects about creating workshops and framings in such a way that we can hand them off to instructors and work on them. Documentations like these. This is a part of the documentation of the puppet that we use currently as our template forward going. And this is how our workshop works. So I don't necessarily report results. We actually have results, but the results that we got educational and learning and impact. That's it. I'm coming over that yet. I'm only reporting about an observation that we did during these workshops. So I'm recording about 2 workshops. We did a total of 4 so far, but I'm talking about 2. One's a student workshop, 8 students, all female, plus 2 of the instructors. The basic workshop breakdown was a little bit like this. Quick introduction, we showed the whole workshop takes 3 hours. Quick introduction, story development, public coding, rehearsal performance with the puppets, and actual final review, especially what happened there. The second workshop was with experts. Experts meaning puppeteers. We had John Ludwig, the creative director of the Center for Contemporary Arts, and Adam Baumgartner, who's the education outreach manager at the center. So real, like, multiple decades of puppet experience. So we didn't do any story development or performance with them. We only did puppet technology tests, basically. Multiple different designs, and we tested different designs with them. So the 2 workshops I'm talking about were designed completely differently, and they had different audiences with different backgrounds, and the results were also different. It's all fine. The observed element I want to talk about is ownership. Oh, that's ownership. So these were 6 participants, and some of the results of the puppets that actually come out of this, look at these. These were done by the students. Their story was about a little bit stupid boy, repetitively sick with his girlfriend, and then people shot. And they created like stage, props, and the whole story about it. So that's about the making puppets. That's kind of what our project is about, and it's a very clear.
Real binary pixels. They incorporate their knowledge of strokes and substrokes.
I want to talk about ownership. Holding up the puppet and saying, "I did this."
So they created and developed a model that they felt represented a concrete subconcept that a human might use in parsing, classifying, or generating new characters. And this is the HDPL model that they came up with. A distribution over characters, so the leftmost term up there, is factored as the product of distributions over the number of strokes per character, the number and type of substrokes per stroke, and the starting position and relationships between strokes. The model each of those concepts separately. And having decided on that model, they derived empirical distributions to represent each of those sub-concept models and them, of course, really well. Better than humans in classifying similar characters, and nearly perfect results with our certain test of newly generated characters. So what does this have to do with new? Well, instead of handwritten characters, we can use the HTML framework to build a model of music composition. And what genre of music? Well, that would be akin to the MIT group asking characters from what language. Rather, they built a model that was ignorant and using kind of concept. So in our case, the model we build would be ignorant of any specific genre of music. So what are the strokes and substrokes of music generally? What sub-concepts span the breadth of human music? And here we arrive at a seminal contribution by Thompson and Whitney on these points.
Embodiment, who's creating what, who's driving what? There's kind of a question that kind of popped up in the question of what does it mean to have ownership in this workshop. And one of my favorite posts regarding publicly came to mind, Robert Wilson, director of TIA Canada, and one report is a publisher for. And maybe that kind of would help you to understand how that happens, how this idea of the public takes over can happen, which is amazing. So to return, stay within my 10 minutes. The two main points are the observed effect of increased ownership in what we do with our public workshops can be fed back into two main items. One is the combination of different creative practices, narrative, making, and performing, as the students gain more and more and more support. And the other one is the question of embodiment and the tension between public and volunteer. That's an open question, and I don't know what the answer is yet. I thought I loads of questions that I have about that stuff. And I'm not quite sure they will relate to this session, they might relate a bit to the last one, especially the robot one actually. But the idea of how does shifting roles for instructors work, how does material work, and how does collaboration work. And I'm done. I say thank you to the NSF for funding all of this. Thank you.
Thank you. Let's get the next speaker up, and Maybe while you're setting up, Michael, question? Anyone have one? If I have more involved in that. Up next, we usually have blackwork embroidery pattern generation using a parametric shape. So we'll all try to say that.
There you go.
Yeah. So what does that mean over on this side?
We're not so sure about that. So.
That might have been good timing.
I'm not even clear
I mean,
how you're putting into that. So I think you have 3 displays now.
Get back on one.
Yeah.
I don't know how to access that.
Well, that one will not connect to that.
Oh wait, this is somebody else's.
Yeah, that's
That's
Yeah.
Oh, good. All right. I'm presenting my work on blackwork embroidery pattern generation via parametric grammar. I'm April Grow. I'm obviously not Michael or Noah. But, real quick, I'm going to talk a little bit about me and my background because it is deeply interconnected with the things of this workshop and everything that we've talked about so far. And then dive right into why blackwork embroidery? What is it? How does it work? What's the tool look like? Where are we going? What am I going to do with the damn thing? So real quick about me, I'm a 6-year PhD candidate in CS, but I have a background in video games, AI for autonomous characters, and I also make a bunch of physical crafts. And a lot of this is stemmed from the idea that, women were an extreme minority in my group, and when I talked about crafting in games, I would get stigmatism from the men and super excitement from the women, and so there was always this internal drive to explore crafts and games. So I made a crochet educational game that uses the Xbox controller to introduce the manual dexterity of what it would take to crochet using the 2 joysticks as yarn and hook. And there was some alternate endings. You could change the color of the yarn that you use to represent different things, and that was sort of the idea of the game. It was very successful and getting people excited about. I'd never seen anything like this before, like crafts and video games. And then fast forward a whole bunch. Recently, you might have seen some of the work that me and Jillian Smith and what we did during a workshop when I was at Disney Research Pittsburgh 2 years ago. We created thread setting, which was originally made for a long arm embroidery machine, a long arm quilting machine, and we made a portable version for an embroidery machine. And we took it to IndieCade last year, and it won the technology award. And the year before that, we took it to Control Up GDC. And it is a game that you play on the embroidery machine, where you have, or on the quilting machine, there were buttons attached to the sew head that you press to take your turn, and then it sews your turn on the board. And the idea that you could play in real time and that you could never undo the turns that you took, and there was no cheating, and the game was not allowed, it was really kind of interesting. But the sort of precursor to all that was hacking embroidery, and particularly blackwork embroidery, and realizing it on an embroidery machine, which is sort of what motivated this research. So why blackwork embroidery in particular is extremely geometric and contained and restrained embroidery domain. was made popular in the 1500s, where it was worn on Queen Elizabeth, I can't remember which one, a lot of her collars and her and the sleeves of her coats. But nowadays, people use it as sort of a repeating, self-similar geometric pattern that's used to fill various designs. It's just a particular style, generally done in one color. But we wanted to, this kind of domain was perfect to restrict the literally limitless possibilities of embroidery into something that was containable in a grammar form and so will read quite easily. So the idea is that we're on a grid on this even weave fabric you can see over here, and so we have 1 point and 8 potential neighbor vertices. You can think of it as like a pixel and having Moore's neighborhood of having neighbors. And the grammar is simply there's a vertex, and any vertex you can turn into a vertex edge and then another vertex. And you generally, the grammar was simply you start with a vertex and an edge and another vertex because we wanted to avoid the sort of like same problem. There was always something that was sewable in the world. And it would just, and any viable vertex, it would just invent all these rules. And if they were viable, as in if it didn't already exist already, then it would say, okay, we can keep that or not. And then we started looking at how does the computer understand sort of what would aesthetic beauty even look like? What does the computer understand? And the most basic level we thought, well, we know every vertex has a bunch of neighbors. How many neighbors does it have? Does it have every neighbor? Is it connected to all of them? And that was really sort of a dense vertex. Was it stretched like equally in some manner of feasible arrangement, like if they were across each other or in a y direction? And we called those sort of balance scores. It was very kind of a loose idea because we weren't confident that like, oh man, if it had like a score of like 10.0 on balance, then you would definitely make like this perfect embroidery design. This is like a creative domain. There isn't anything nailable like that. And so we just sort of had this idea that the density and balance was different, and that if it was up to the user, they could go for different kinds of expansion. And so, for example, the flower in the corner there, oh my God.
Yeah, don't do this.
I didn't do anything.
You have to change the channel on your laptop.
My laptop didn't change the channel.
Turn to UHF.
My laptop does not have that control.
Wrong generation.
UHF. Broken.
Static sound.
This is in the wall, clearly not.
I didn't touch the cord, I swear. I did. I might have. Sorry. My gaze has powers.
Is it
Yes.
the cable?
Just the cable and the box.
Okay. Anyway, the example of this flower, for example, 2 is an example of these are highlighted in pink are all the available edges, and as you successfully go through the different options, you can see, for example, looking at 4, in order to like increase maximal density, these 2 edges would make this point have all of its 8 neighbors joined. So if the user was going for maximal density, those are the 2 edges that you would think of generating as the next rule selection. Whereas if you're avoiding edges, you would go for 5. Avoiding connections, you would go for like outward reaching. And if we wanted to make edges that were minimally connected, that were literally branching off of a point that had one, that minimized the density on both of the endpoints of the line, you would go for 6. And so it would only branch off of the lines that had currently 1 neighbor. So these are just sort of rule options that we had to try to communicate to the user, but like not in a I don't know, it was really the step of how to communicate with the user is a big open problem. We just made a bunch of buttons, like the buttons that do this, this, or this, and the user could just click on the buttons and try it out. And so that was sort of the grammar expansion. And then I mentioned self-similarity. One of the easy ways to get an appealing embroidery pattern is to just replicate the thing in various different ways of reflection or rotation. So there were two stages of either replicating, rotating, reflecting the various design, whatever design was made, and then repeating that in a variety of ways. Because Blackwork, you think of these hundreds or thousands of lines, it's really tedious to visualize. And so if nothing else, it could be a visualization tool for seeing the pattern if the user didn't really know what they wanted to make. And so, like I said, we made a ton of buttons, and then we gave it to some users in sort of an informal setting to play with. These buttons do make different designs. You can see up there, sometimes they kind of look like circuitry, sometimes they'll just go meandering, sometimes they'll get really dense and gnarly. And then the examples on the bottom are examples of given one design, and these are the kinds of different designs that the post-productions can give. So just rearranging one design in many different ways, it's a whole bunch of different visualizing styles that the user might like. So yeah, here's a bunch of examples. I can only say is it spit out a bunch of stuff. And then we sewed it using a depth first search algorithm because this was all based in the graph, and it was awesome. People loved it. So future work, we're looking at different ways that the computer can interpret the designs rather than just this really simple low-level density and balance. Having the AI suggest things other than without user input, and to applying it to other domains other than just Blackwork embroidery, or looking at arbitrary embroidery. So yeah, because of technical problems, we have really short time, so thank you everyone.
Brilliant. Can we have the co-creative intelligent agent for all of these? If anyone has maybe a single question, a clarifying question, or wondering about that last round slide.
So may I tell Professor something? I believe the project is working. So they just try to switch them. Oh, we don't do that. Yeah.
Well.
Sorry about that. So Brian tells us we are behind on time, so no lunch for you.
That's what I was trying to do.
Exactly. This is the deep south. That's how we treat our guests.
That's what I was hoping. Okay. You got it. That's also
Can we test that?
Why don't I test it out on my laptop?
All right, that's okay.
We will keep this for this presentation and try to, whoever's the next presenter, when this seems ready, please go set up over there and we'll all just shuffle to the other side.
Sorry about this.
All right, so you have about 5 minutes left.
There you go.
We're just one thing at a time. He's wrong.
Hi, I'm Jamal Oberlin. I'm from UNC Charlotte. With me also presenting is and Lena Lee is also in the project design. So we are starting to think about the design of a co-creative intelligent agent. specifically for gesture-based creativity in elderly populations. So we're starting to think about what the behavior of this is going to be and what some of the requirements are going to be. But towards that, we are presenting a system called Move and Paint, which is just the gesture-based creativity with elderly populations. So in general, the elderly populations are understudied and under-designed for. There's a number of challenges that interaction designers face, and a number of challenges that elderly face in trying to use technology, a lot centered around social issues and stigma, and they're stereotyped as being not able to use technology, which makes them less likely to want to use technology, and they lack confidence, and not that they can't use it, but it's just all of this sort of social stigma that goes on around it. There's a number of opportunities as interaction designers to take advantage, things to leverage and things to be better. For example, leveraging the social interaction, making it more of a collaborative thing, considering the different mental models of these different populations, aiding them in the learning, understanding that they do have that feeling of frustration, and that's giving them the confidence and understanding that it takes some extra steps at the beginning. And we also see a co-creative agent as another opportunity to start to explore for this particular population. So Move and Paint is a gesture-based interactive system. It consists of a vertical screen, a Kinect sensor, and an interaction area of a number of feet around the area. We designed it to be playful, social, creative, promote physical activity, and we're mostly just interested in what would happen when we put the system into a public space with different populations, what sort of interactions happen. And this is a video that shows the interactions with the system. So when it senses a person in the area, it provides instructions about where to stand. It'll tell you to come closer, but if you're too close, it'll tell you to back up and indicate there's a line on the floor. And once you're in the correct position, it will instruct you to raise your hand, at which point tracking will begin, and we hope that the interaction would be obvious enough that you can sort of start to explore and discover it on your own. More advanced features are around the peripheries of the system. You can change color, you can change brush, you can change the background, so you can either do pre-coloring mode or you could do coloring book mode and use some existing images. So we studied the system in 2 different locations. We left it unattended for a couple of weeks in a multi-purpose room at an assisted living facility. So this was a room that was used for activities, so people were sort of coming in and out. Social gatherings would happen there, so people were just often milling about in there, so we got a couple of different kinds of traffic. We also separately left it up in a college library social space, so this was a study space, there was a cafe nearby, people would pass by all of the time. And this was not a comparative study. There were enough differences between the 2 locations that wouldn't allow us to do a direct comparison. But studying the same system in these 2 positions gave us sort of a frame of reference in how these different populations interact. And in each location, we also studied 2 conditions. So we studied it with instructions, as you saw in the video, and we also studied it without the instructions. So you just walk up to the system, and it wouldn't tell you where to stand, and it wouldn't tell you how to interact. So for analysis, we had video cameras and the system would take screenshots every so often. We looked at how people approach the system, we looked at how they learn, and we looked at the nature of their so for both the version with instructions and the version without instructions, the elderly residents were a lot more hesitant. It was more often the case that they would walk up to the system and stop and just look at it, whereas the college students were a lot more active and they started to explore, try things, and they would, if they were engaged enough to stop walking and hear the system, they were always doing something. Both populations, though, tried actions that didn't work, so a lot of people walked straight up to the screen and would try to touch it, or they would pick up the cameras that were video recording and try to use them as pointers or something. So that shows that existing mental models affected both populations. Hard to say which population it affected more. There were a couple of elderly participants who recognized that it was a computer and were looking for a mouse, and couldn't get that out of their head. There was actually a mouse sort of tucked around the system for facility issues, and they found that And so we're so intent that the computer had to have a mouse. We're searching for the mouse as opposed to trying to find some other ways. We also looked at the learnability. So elderly residents were less likely to figure out the interaction, less likely to figure out the gesture and the wave interaction without the help of another person or without instructions. So in the condition without instructions, the elderly residents were often asking where the instructions were and asking how they were supposed to know how to use the system, whereas that wasn't the case with the college students. And lastly, we looked at engagement. So for the people who stopped and interacted with the system, the length of their engagement between both conditions and both populations was largely the same. It was about 1 or 2 minutes. But there were some interesting differences in the nature of the interaction. So for the elderly, they seemed to be more focused on just the interaction technique itself. So they would make sort of repetitive gestures, or they would make sort of up and down lines. They were very focused on just sort of the effects that their actions were having on the system. They didn't explore so much the different interface elements. They didn't try to take pictures where the college students did. The college students would change color more often, and they would figure out the interaction relatively quickly, and then try to draw something or change screens a lot of times. Also, the physical stance and the physical exploration was different among the population. So the elderly would tend to assume sort of the same stance, sort of standing straight up with one arm out, sort of in that same general area, whereas the college students would be a little bit more explorative than physical. Different gestures, they would dance a little bit, they would use one hand, they would use 2 hands, sort of explore the physical space a little bit more.
And in the spirit of creativity, we decided to focus. And so I'll be just talking about this last slide so that Brian can use the running got my 10 minutes. But designing for special populations, whether it's designing for creativity or designing for the elderly or designing for children, often brings out things you wouldn't think of if you were just designing for the general population. Another problem we see in HCI and computational creativity is whenever we do studies, we usually study them with the people we have close at hand, which are college. And so actually testing it on a different population is also really important. What we did was we transferred our findings into design principles. And these are design principles that we think are specifically true of the elderly, but can also be true of any co-created system. So sensitive. It needs to be sensitive to the population you are designing for. We found the elderly were really focused on what they were doing. If anything went wrong, the elderly tended to think it was their fault. College age students, if anything goes wrong, they think the system's bad. Right? So that's a really different mindset. And so any co-created system should really focus on what that elderly person is doing. They're not going to stray from that, so stay with it. The other one, engaging. The elderly were more likely to continue to interact at all if there was another human present. There were no way to do it on their own. So co-creative systems should actually engage the participant as an equal, not as some automated out there, some super just as that person. Instructing the elderly were less likely to try gestures to figure it out. So a co-created system, no matter what its intent is, should have some aspect of the co-creation process interaction. Should include some instruction, particularly encouraging. The elderly were less likely to explore new features. One role of a co-created system could do is encourage curiosity. Just observe what it is that they learned that you're doing, and take them just one step further. Start to engage them in something novel, something they haven't tried yet. And that would also lead to creativity, but more importantly, it would address that regional model issue. And then ownership, the elderly are more engaged with the interaction than the drawing itself. That's a really interesting finding. And so the co-created system for this population, the many co-created systems we talk about, focus on the product of the thing that you're making. In the code-based system for the elderly, it may be more important to engage and encourage interaction. So exactly what we're focusing on, rather than fun.
So, to give you simple, you'll come again at lunchtime, you will speak at lunchtime. So you can still have your lunch back to you. But the time you will come
Yeah, there's a question from the last one.
I thought the task was interesting, the drawing task. There's some bias maybe towards younger people. Maybe it's a straight up about other people do color. I was wondering if there's other tasks that you would consider in that environment.
The way we got to that task was we actually talked to them. So we spent a semester with them in their environment. And it was something that we were considering. So we did come up with other tasks, but that one was based on.
So focusing on whole body interaction with physical restrictions an issue.
They could do it with the wheelchair, with the walker.
Yeah. So people, it was just generally.
Actually, the intention was to encourage physical activity. That was the design group. The creativity part was there.
Yeah.
To the left.
No, I'll just do this then. So my name is Stephen McNeil. My co-authors are Selena Fulop and John Okerman, just presented actually. I do a lot of research on design and education and reflection, and this is sort of something that came out of reflecting on conceptual spaces and thinking about concept generation tasks. Design space, I'm sure probably most of you are familiar with them, but design spaces are ways to categorize different aspects of design. So on the left, we have a design space of input devices, we have different form factors, they have different input types, whether take a photo or record your voice or change the XY coordinates on your computer. And then on the right, we have a design space of vehicles. So you can see that a design space can be very constrained or it can be very open. And design spaces are used pretty frequently in research. So on the top, we have the design spaces of so the active tokens. And are you using one token at a time, or using two tokens at a time? Are you using one hand versus two hands? These are all the different things that you might consider dealing with that design space. On the bottom, there's a table view of design space. You can see examples along the rows, and then each of the different columns is a different aspect. So, what is the primary purpose? Who is the target audience? How is it used technically? These are the different dimensions that we consider.
And so we created this tool, Design Space Explorer, which allows you to construct design spaces and explore them again. This is my work with Chapter at ICCC. So there's three main aspects to this. The first is creating dimensions. And you can kind of, obviously design is iterative, so you can go back to any of these stages at one time. Create some examples and you find new dimensions and let's go back. But typically we start with dimensions. We're going to create, this is for automobiles, you have dimensions like miles per gallon, the engine size, the top speed, the number of doors, the engine type. There's a lot of different dimensions that you consider. And once those are created, you'll go to the next page, which is this example page. And then we're going to create a specific example that might exist within that space. So you can think of this as a design analog. So something like the Ford Mustang, the engine size, which we mentioned from before, becomes a selectable widget. You can say, here's cylinders, but you can click on that to choose other engine size. And then mile per gallon, because it's a continuous dimension, you can select a value between, in this case, 5 and 60, which is what they specify for that function. And then finally, you get to a coordinates chart that shows all of the different examples. In this case, we have Ford Mustang, Lamborghini, Toyota Prius, and Honda Accord, and different selected values for those. These are not at all accurate. This is just something I totally made myself, so don't hold me to the top speed or like that. So the idea of what we're doing is really about construction. So there's a lot of work with parametric design. We saw an example a minute ago with the sewing example. And in that case, we have something like a design space on the left, and we have all of these different options that we might choose from. And as we make choices, it's going to constrain our future choices. And the same thing, we see the same example in architecture, sewing, all of these application domains. And the idea here is really about constraints, and we need to know what are the possibilities ahead of time. So we have to have a really good understanding of our design space, and then we put it in here, and it's really about finding an optimal solution given constraints, given design decisions. And we're not really doing that. We're really focused on the construction and curation of these design spaces. So here, this is just quick results from our first study. And these kind of motivate the reason why we're looking at co-creational agent. We have these two different visualizations. These are from participants in our study. On the top, you guys can see that it's a pretty well-covered space. A lot of the options have examples that touch them. And on the bottom, we see a kind of poorly covered space where that bottom row, for instance, none of those options have been selected by any example. So in general, we saw the spaces represent, or were most represented by the bottom image here, not by the top image. The top image was kind of an outlier. Generally, the spaces are very simple. We have a few dimensions, a few examples that our participants can think of. They chose dimensional topics, so we had them do this for their research. And if their research wasn't obviously dimensional for them, they might choose something that they were familiar with, which wasn't actually their research. So whatever they perceive to be easiest to dimensionalize, so we choose to dimensionalize. We found that they had a lot of homogeneous examples and poor covered space. And this is kind of a problem because it's kind of expected too, based on what we know about design fixation and getting fixated on sort of the things that you're familiar with. It's really easy for us to come up with similar ideas and not really explore the space holistically. So these are also problems that if we know that we're fixated in subspaces and we see that they use our tool and create subspaces, we're not creating a holistic view of their conceptual space. This is really, really challenging in terms of having them creatively sort of new things or explore parts of the space that they may not explore. So we're thinking that a co-creational agent might be able to help with this. And we're thinking in two main ways. The first being by co-creating examples. So can it find parts of the space, examples that touch areas of the space that they haven't explored yet? And it might suggest one of these examples to the participant or to the user, and the user might pick an example that fits that, or they might be able to create an example that would fit that And this leads to kind of like a convergent thinking, because as we think of more examples, we start to cover the space more, we start to see the space sort of like more constrained. And then the other option is co-creating dimensions. So this is more of a divergent thinking. Our co-creative system can see two things that are very similar and say, based on what we're seeing, these two things are identical. There must be something that differentiates them. Otherwise, they might be identical. And so the co-creative agent could suggest what would be a dimension of differentiating them. And so then the user is going to provide that dimension and then open up the space. So here we see what they might look like in action. Again, we haven't implemented this part yet, but on the top we have the co-creating examples, and we want to try to create a new example that's going to increase the entropy of the space. So what is the biggest outlier that we can introduce to this space? So in this case, we have, it says give me a name, you might click on that and add the name, and it's doing 60 miles per gallon. We don't think it has 60 miles per gallon yet. It has very low top speed, it has 8 seats, and of course, some dimensions. Those are the things that have really not been explored so far in this space. And in this case, maybe the user would change the number of seats because that doesn't make sense here, and select 2. And then right here, you have a smart car. So you have 5 miles per gallon, low top speed, 2 seats, that's a smart car. So there are examples that you think of that might be fictitious problems. And then the same thing for co-creating dimensions. So we have the 2 points that are the most similar. We have here the Honda Accord and the Toyota Prius. They have similar top speed, they have similar engine size, similar miles per gallon, similar number of seats. So what is the thing that differentiates them? It might be something like engine. And so for both of these, I think we have a few problems. We're dealing with potentially categorical dimensions, and so they're not necessarily ordinate. So when we're thinking about things like using distance as a metric, how do we say that hybrid and electric, or hybrid versus electric versus gas, and how different are they in terms of distance? So that's definitely one of the challenges. Another thing is that they might not be ordinal. So something like they might be ordinal in terms of input, but they might be non-ordinal in terms of output. Something like mile per gallon between 0 and 60, but let's say that you tax rate for any car that has more than 40 miles per gallon. And yeah, these are basically the main things. The different principles we have, the goals, co-creating examples, co-creating dimensions, the different metrics that we think are possible, and obviously we have a lot of questions still to get to this working. If you guys want to try it out, there's bit.ly at the bottom. It's just bit.ly DS Explorer. Yes, shot. Thank you.
Here's the guys. That should have on the side. Yeah. Yeah.
This has been so exciting. I could have used my laptop. he just used it for his.
Right, it should work. Probably extend adding just switching between the different things. Goes to
Okay. Alright. Alright, hey, I'm Kate Compton. I'm part of the UC Santa Cruz Expressive Intelligence Studio. This is a sort of metastasized side project that started at ICCC 2015, but I've really enjoyed it, and I thought I'd bring it back to ICCC to present where it's gone since. And yeah, this is work done with myself, Jonathan Pagnuti, and Jim Whitehead, and a variety of other people who have offered input and advice. So yeah, who has heard of tracery? Has anybody not heard of tracery? Many people. You should definitely grab one of those zines. So tracery is this language that I rather accidentally wrote a number of years ago, and it's a grammar expansion language. So you write a grammar over here in like a JSON object or a JSON object, or a JavaScript object or a JSON object, which gives you your keys and your expansion rules. And then there's a syntax for templating within it, which can sort of recursively expand things out. So here's a conference generator slowly expanding itself out. So like a project is an examination of a thing, of an examination of another thing running on a system. But you don't need to know like a lot about that. You just need to know that it's an expressive generative language that is, its program is data. So yeah, it's a context-free-ish grammar expansion language. The grammars are data, which will come into play later. It's become like phenomenally successful and beloved, but this talk isn't actually about tracery, except that you need to understand tracery to know why I got this far on this project. So there's a ton of active bots on cheatbots and Click, which I'll mention later, and infinite numbers of cheatbots and Click projects. I mostly hear about them when people tweet them at me. And people really like it. It's been very simple to use. If you want to know more about tracery, definitely go to tracery.io for more, or ask me for a zine or tutorial later. But yeah, so the fact that these grammars are data is really useful for this project, and I'll talk more about the actual project later, but like JSON is safely hostable and runnable. You can't screw things up on JSON. This allowed, I open sourced this language. Somebody made a hosting platform called cheatbots.quick where they allow people to upload their own JSON and have a live Twitter bot running on Twitter and posting every 30 minutes. And that's why there's like 4,000 of these suckers. It's also a little language. I really like this concept. You can learn more about little languages there, but the idea of a little language is that it can often generate other languages and take other languages as input. So tracery can generate other languages such as HTML, SVG, ABC notation, which is music. It can in fact generate it itself, which will be useful in this project. And it can be generated by other languages. So I can use JavaScript to create these grammar generators, which is also useful. And yeah, there's like I made one of the things that happened when I made tracery at first is I made a graphical UI that people could use to edit things instead of operating strictly in JSON. And this was really huge because it turns out that one of my top users doesn't write JSON. They're afraid of it, and so they really like this. And this is the person who has made like several hundred bots, and all their bots have like 5,000 users or 5,000 followers or more. And like, yeah, you get a lot of really interesting people if you allow people to create bots that don't know how to code. And so a lot of this the next part of this talk will be about like why I really want to recreate the success of tracery, but with co-created bot making. And yeah, it's got a couple of useful things, like it's very error tolerant, it's highly modular and reusable. You can rewrite bits of the grammar, so you can replace symbols kind of on the fly, and it'll still generate stuff. You can also do manual and automatic tagging. This is a fancy toast generator that I'm making for a hipster chef simulator, and I can actually like make tags within Cream to say that certain tags contain nuts or contain citrus. Like in any form of data that you're doing, there's always like special casing, and this language makes special casing really easy. So Techne. Techne is this project that I came up with at ICCC of 2015, which is like, how do you make an environment where bots and humans can kind of be co-creative all together? it's inspired by digital ecosystems, such as like digital clockwork muse and the painting fool that encode this concept of digital creative, like sort of digital digital ecosystems of creativity. But for technically, we wanted bots to talk to other bots. We wanted anybody to make a bot or to make a thing that makes bots. We wanted to have duck typing where we're not strictly controlling. This is the JavaScript concept of if it walks like a duck and talks like a duck, let's treat it like a duck. That as long as you implement a function that says like I can appreciate your art or I can generate art, you should be able to play in our system. And bots can learn from each other, share tools, or adapt. There's a paper on Techne if you want to know more about it. And yeah, so we made all these little bots, and they can kind of evaluate their own art. They can make different art. Their art kind of has styles. Here you can see some art trying to evolve to improve its own preferences. The preferences are not very smart. They're just like a bot has a favorite color. Yeah, but the question we kind of ran into here, our bots can generate all sorts of stuff. So they can generate like music or drink recipes or art or poetry or whatever, conlines. But how do you have like a bot who makes art and wants to appreciate cocktail recipes? How does it like learn what other bots can talk about? And then how does it like share information between bots? So we came up with this idea of Cheap Artists Done Quick, which is a knockoff of Cheap Bots Done Quick, which is that hosting platform. Because I really wanted something that's like a lingua franca for bots to communicate across genre. And I needed some form of data structure that I could actually talk about how these bots are communicating. Like it would be very hard for a neural network bot to communicate with a grammar bot. What would they say to each other? Or for something like incredibly custom like the painting fool to talk to anything else would be nearly impossible. So how do I make something so that everybody can make bots with this language and they can like have a conversation? And I also wanted to have a platform so that people could run their bots on it. So yeah, I really wanted this concept of style. So like bots should have style, and we should be able to see that like two bots are making different kinds of stuff. But I also want to be able to recombine their parts in different ways. So like if I have pink Legos and pirate Legos, I should be able to combine those into some way that you can clearly see that it's using bits of pink Legos and pirate Legos and doesn't crash the system. So I came up with this concept called genre recipes, which is like a recipe that creates a kind of thing. And I'll do a demo shortly. But mostly you have like a library of genre recipes. So maybe I have something that makes cocktail recipes and poetry and conlines and art. And for my poetry one, I have some number of sockets that are these tracery grammars for how like different sets of rules for each of your symbols. So okay, so this is going to get super complicated. I'm really sorry. I have bots that are creating bots that are creating bots. But the important thing is with this language, I actually was able to do that in a relatively same way. So for a poem, one of my sockets is the adjectives that it knows about. So if I'm going to write a poem, I probably need to use some adjectives. And it has some options for sets of adjectives that are poetic in different ways. So there's like Verdant adjectives, like maybe I just use Verdant adjectives, or maybe I use adjectives about taste or texture. And if I'm creating a bot out of this genre recipe, so this is going to be like a little generator that can generate poems in a certain style, I might pick like verdant and ocean metaphors. So I can create like verdant lighthouses. And you can see that here, maybe, where this bot has picked happy and country. And it also has a couple of line patterns that it can use. And this one has selected melancholy and universal, and its subject is my captain. This one is talking about my love. So, you know, if my captain leaves of an everything, if my captain leaves of a self, if my captain leaves of an everything, if weeping and forgotten. So you can tell it's clearly using some metaphor. It's clearly got a style here. Ask me for a demo this later. It makes pretty funny stuff. Yeah, so I wanted to switch over to the demo now, because I have a couple of demos, and everybody pray to the demo gods. Okay, cool. I know. And I know we want to get it to lunch. So yeah, so here it is actually running. I've generated a whole bunch of bots here. A couple of the bots are analyzing each other's works. So here's a conline bot that has generated some really terrible conlines and is writing poetry in them. You can think of this as kind of bot Twitter. This is where all the bots are posting. So here's a bot. Here's some other bots in the system. Oh, here's my conline bot. Yeah, I don't know if I can actually see the the grammar is here. But the important thing is bots are talking to each other, and I even have a bot option in here that it's not a tracery bot, but it makes a JSON request to the Shakespeare archive and just repastes Shakespeare in. And there's also there's bots up here you can't see. It's using text. If that bot reads text, it adds that text to its grammar, and it can then use that text in its posters. So if it reads some Shakespeare, it can then start pasting Shakespeare into its art compositions, so concrete poetry, whatever it's recently read. And I know it's super hard to understand a lot of that, so I made something that's even harder to understand, where we have this sort of, so this is what's going on in the grammar generator. So these are my recipes, and each recipe is creating a grammar. So let me switch this to, so this is currently making conlangs. So I can make new constructed languages with this. And for each constructed language, I can make lots of different poets in it, or lots of different poems. So I'm constructing the poem, and so I'm constructing the poet, and then I'm constructing the language that the poet is going to use to make poetry. But I really like the poem one the best. So here is my total selection. So here are all of my options, which have different tags, so I can tell when different bots are using which tools. So if a bot starts sharing its tools, I can see that pattern go through other bots. And here I've got a bot who has selected universal nouns and adjectives about aging. So it's making universal poems about universality and aging. But I could, and we're out of time. Anyway, ask me for tracery tutorials or to see more about this. It's actually really easy to just edit these. So if anybody would like to help add new nouns and new adjectives for the bad poets, that's actually really fun, or we could even make new recipes. I added a fancy toast generating bot this morning.
Great, thank you. Thanks to all our presenters. We've got one paper that's not going to be presented, it seems. The presenter is MIA. And that's from the first session. So that's the research tool to quantify interaction dynamics. That being said, anyone who's going to creativity and cognition will also be presented there in a week at a much larger scale. So we have time, a little bit extra time for doing panel discussion. I was hoping everybody who just spoke, including Michael, could come back up to the front.
Not present. No, I know, but the camera broke. I know. It's really bad.
So I thought there were a few of themes that definitely stood out. Some may be explicit, and some others may be more implicit. The notion of ownership came up quite a few times, and seemingly kind of with this almost constructionist bent. Like there's very much this idea of having a thing that I made and sharing it in a social context that I thought was maybe not with everyone's work, but definitely common across. And even within, weirdly within AI sharing with each other maybe or something, I don't know. Another, almost everybody here is focusing on embodied interaction as well, either with the physical environment or with the computational environment. So I was hoping that folks here might have their own observations or questions for the panel in general, or even specific questions for speakers. Please.
The concept of ownership in a co-creation context, for me, it's kind of paradoxical. So maybe it's my misunderstanding of the concept, and please correct me if it's so. But the idea of me owning what is being co-created, maybe detrimental, maybe for what I'm trying to do. And the other thing is, what does it mean for a computer to own something, and how can we accept the idea of a machine designing a piece of art or whatever, even if a human is part of the process? And all those questions for me are kind of hard to make sense right now in my mind. So you have been working and thinking about those things probably. If you could like me, enlighten me, so I will
So
So ownership for us is not necessarily a target. It was more like it happens. It was an observed activity. Maybe it's not helpful in the development of a computer system that co-creates with me as I go along. But on the human side, it was something that was observed as something that is manifesting itself. There's nothing I can do about it. We didn't expect it to happen. It's not something I would redesign for or that we actually targeted. It's more something that came, that was a result of the activity itself, of the procedure. So I don't think it has to be a blocking stone for the development of a co-creative process or a co-creative partner. It's more an effect that seems to be active in a creative activity, such as making paintings, bots, or puppets at all.
I would go further and call it a force. So it's definitely a force that is, I think, well, so my dissertation is about casual creativity, and one of the most powerful things of getting people to like your system is for them to feel ownership over the creation. So I worked on a little game called Spore, which had lots of AI, and Spore explicitly said, you do not own what you create. And that did not matter at all. People still felt ownership of what they made. They would post it, they would brag about it. So if somebody uses your system and says, look what this system made, I found that to be orders of magnitude less powerful than look what I made. As soon as your system disappears and it's them just feeling powerful, that seems to have an incredible, and I haven't done studies on this, but just seeing it like in AAA, it seems to have an incredibly powerful effect on how much people enjoy the system, how empowered they feel.
Yeah, part of it's probably generational as well. It was interesting, some of the elderly participants commented explicitly, even without an intelligent co-creative system, when it was just them using the gesture-based art system, they would say things like, I didn't make that, the computer made that. And so we thought maybe a co-creative agent might actually help them realize their own agency in the system, that if there's another thing in the system making lines and things, they realize that the lines that they're making is not the computer, it's actually them making the line. So it could go either way. A co-creative agent might make it seem like it's less my thing because I'm helping somebody else make it, but it also might make it seem like more of my thing because I then, for the first time, realize my own agency within it.
So, question about interaction, and this especially relates to your paper, Johanna. You mentioned that there was a lot of focus on the participants' part on the interaction rather than the product of what it is that they were creating. And that made me think about how user interface becomes an essential part of co-creation, more so than it would be for other creative systems that are not co-creative. So this is a question for the general audience. How do we design interfaces that support co-creation as well as evaluate them in a way that we're evaluating the co-creativity and not the interface itself, since that would play such a big role in the system?
In this way, you have to basically teach the user how to use the system. You don't have to make the system super easy to use, but the opposite that you teach. So when I saw the difference between the elderly and the young people, that's I'm presenting with also something where we had kids age 11 using iPads to design something, and we had researchers using the same app, which are like 30 years older. And the difference is they take the iPad, the kids, and just touch stuff, and just they don't try to understand, they just explore. But the older you get, and the elderly people, there's a disparity of just, it's so hard to get into the technology. But once they basically reach that point, when they are able to understand and use it, then you don't basically need to do that anymore. So you basically need to make a transition. So with when I saw the Kinect stuff, I would have gone maybe with the PlayStation remote control first, because it's something haptic, like an intermediate step. Because that step is super far for somebody who never used any digital technology in that extent, to go to something where it's basically ephemeral. So you just stand in front of the television. Try to touch, because it's the closest thing they could get.
So there were really two big questions in there, I guess. The second was on evaluation, right? How we look at, like, what does it mean to look at kind of this computational system versus more of the social context, right? Unfortunately, that's the topic of the paper that's going to be presented. But some of the work, so one of the co-organizers, Nick Davis, who couldn't be here,
His dissertation work has been about looking at how to quantify interaction dynamics between agents. And agents can be people or some mixture of intelligent, presumably people, and agents. Like without getting into the presentation, I'd be happy to show you the paper later. It's very much about trying to look at how the different kind of modes are cognitively that the individuals are in, within the sense of how they engage in participatory sense making. So how much are they in here versus how much are they executing kind of a plan to some extent versus how much are they thinking and acting through the environment. And the hypothesis behind all that is if you can look at those quantitatively, like individually, and then map them on top of each other, then you can maybe start looking at comparisons between those behaviors as well as kind of an overall gestalt about what are the qualities of this interaction. But it's really a huge open problem, like how to look at that social level, right?
I think that a complement to that is to look at affect.
Yeah.
So there's a lot of studies out there that say positive affect encourages creativity. I think that two things that came up so far, ownership. I think ownership can be seen as a block or something that people feel uncomfortable if the computer starts, the co-creative agent starts, for example, in the work that Nick did, works on top of their stuff. It's like, don't touch my stuff, do yours over there, but don't mess up my drawing. And so that ownership thing can become a negative thing, or as Johanna said, it could be, if there was a way to design the interaction where that ownership became a positive thing, where you enable the person who is a human component to realize their own agency, then it turns it into positive. And I think also with respect to the interaction itself, how would you evaluate it? If you're developing co-creativity to produce creative products, you want to evaluate it in terms of affect as well. How did the person feel about it? Did they feel positive while they're engaged?
One of the differences I think is the output as well, if it's performative versus like an artifactual, is that a term?
Yeah.
Yeah, because we've seen definitely ownership in dance to be far, far different. Like, was that your dance? Was that your movements? Of course that was my performance. But asking about a collaborative drawing where maybe the AI was a little bit better or contributed more than you did, especially as novice, really across the board, sitting back and looking at that thing and going, oh, well, here's the part that I did. That's all not mine. It's a lot easier to kind of sit back and judge as opposed to that more temporal interactional stuff, which I think is more forgiving.
So going off of that, say we have the drawing in the little corner and the air, whatever it's done the rest, but it's been building its other corners of the picture based off of what you've done. Again, to me in my head, first off, let's define ownership. Second off, that's a form of ownership to me because it's now being built off of what I'm already doing.
Oh, I think it's just all in the eye of the beholder. I mean, ownership itself is a cultural construct, right? I mean, so even across like nationalities, there are different views about what it means for an individual versus a society to produce a thing, right? So even in these little interactions, I think it's still like this microculture that's going to really depend on the interactor. And we haven't even gotten to that whole question about, well, does the coder who made the AI, are they one of the contributors? And sure, why not, right?
But I think one of the tricky bits is that it becomes really blurry in practice, like when you say performance versus an object. Like if it's something ephemeral like a performance, they make and again, I just in the example that you're using, they make their own story, they make their own puppet, but then they perform them together. So in all the different stages, ownership changes. So it's their shared story. It's an individual puppet, but then it's shared, performed on stage. And the performance is something different than the shared story or your individual puppet, but all is working at the same time and you play them out. So yeah, you construct ownership, and I think it is something that happens it's a human thing, it seems to be something that I have and I'm looking for, but it's very dynamic and it's not a thing that you can just say, here it is, here it's not, here it is, like kind of morphing all the way. And I think that's the same with bots. I think these are like shared points almost.
So I think it's also important to talk about ownership if you talk about how can we get people interact more in a co-creative scenario with a large different system. But I wonder how good it actually is to think in like binary categories all the time, like in terms of what is your share then, what's my share? Whereas can we also think about what is our common share and what have we done together? You know, and I tell my friends, this is what I've done, but this is what we've been doing together with this piece of software. And I'm thinking, like one way to get ownership to a piece of software is with learning outcomes, right? But the person could actually supply the right cues to the system, so the system can generalize and therefore transform some ownership into the system. In that case, it's not like there's nothing going on in interaction that increases the ownership of the overall system. Too. I think that might be an interesting factor as well if you can still not get people. So I think it's certainly detrimental to say, okay, system owns the artifact. But probably you can get something from saying, okay, the system owns the artifact to a bit because I interact with the system.
Well, I mean, just think about a person, right? Think about interacting with a person, collaborating with a person in any of these ways. What would the question be, right? And then it's, well, is it the person or the AI that's owns it with me? You can even ask, is it the programmer or the parents, I guess, too.
It was a compliment to what was said. What we learned in another project that we will be presenting what we learned is that the most important is that there is a clear notion of the intentions of the social process. So we worked in a co-creation in the context of level design. And what we noticed is that as long as the user is fine, well, right now we're trying to find answers and new ideas for this part of the level, and this is agreed in somehow between the machine and the human, it will be fine and there will be no problem. The problem is when the machine tries to create something novel that the user may not be ready when he was trying to think and work and fine-tune some idea he's been working on at the moment. So what we felt is that we need a very clear way for the user to provide and declare his or her intentions. And of course, theory of mind will complement when this is not clearly made. But what we come up with is just an interface with sliders that we can say, well, right now we're looking for things more innovative. Right now we're looking for things that are more around what we've been working. Right now we want to go back to a previous idea. So instead of trying to find what the user is thinking, we actually put this into an interface which is based on, analog synthesizers, and then the user can actually express without being very, concrete about what. It's just about, right now I feel we should do this or that, and we actually tried to make the computer move those sliders at some point, and it didn't work so well. But at least we got this kind of compromise between, there is some kind of a social contract happening right now. So right now we should be working on this part. We're allowed to say crazy things right now. We're not evaluating. Going back to some of the techniques that when you go to a workshop where you learn about the whole lateral thinking techniques, you have moments to use several kind of techniques, and it's kind of, we felt it should be clear between the user and the machine to know what is going on from the point of view of what is being created or co-created at the time for what. And just to finish, one thing is, it doesn't have to be something that is concrete. It can be something that is more from the user experience with the artifact. So for instance, it's not about creating something which has some physical or maybe digital constraints. It's more, it can be about something that the audience is right now liking and enjoying. But it should be clear what is a success at this point, and it helped us making the interaction more engaging for the user. My 2 cents.
So we'd like to continue with, I think actually I was going to comment on something like that. I think an aspect very important is perception. So how the user perceive the interaction and the co-creation. That also stands for the concept of authorship as well. So if the user is, so one is understand the comprehensibility of the stimuli from a cognitive perspective, then manage the stimuli in the interaction, and then meaningfulness of the interaction. So meaningfulness is a big concept which are inner motive, external motive, and that goes into the personal history of the user as well. So in the last 13 years of research on interactive music systems, I've been investigating along these lines. And I think intentionality in automatic generation is one of the things that comes up recurrently. So if the user can recognize some intentionality in the outcome, either that is real or that is supposed, then there is a sense of identification of the outcome as somehow not my creation, but somebody else. Then if that creation is the creation of the designer of a scenario from above, which has some stochastic or random parameters, which are then decided by the machine, so the machine itself in other is a different matter.
So this has been great on this half of the room. However, this other half is really dropping the ball. So do you guys have any thoughts to share? Please.
It's a little hard to hear people speaking from that side.
Sorry, can you speak up? Sorry, what? Oh, okay, great. So people over here had said some really nice things in summary. So feel free to ask or bring up things that may be repetitious.
What he said over there raised another question. So when you talk about co-creation, are we more concerned about the final products of that creative act, or how good the user feels during the creative act? Rather than, I mean, if the user feels good about using the system and he or she likes using the system, that helps in using the system more, and that promotes this kind of creative activity, but the end game should really be the creative product.
So to be fair, I think that depends on the context of a novice versus an expert.
So this is my dissertation, is casual creativity versus product-focused creativity. There are many things that we do that are experience-focused. Video games are one of them. I was just at an Autodesk summit, and they were very product-focused. And the patterns for the two are wildly different. So you may often find that if you're trying to design for product-focused creativity, you fall down on user experience. But if you focus purely on user experience, you can get things like that. I suspect you found with the drawing app that nobody particularly liked the drawings that they were making, but they enjoyed making them. People who do crafting often find that they end up with a pile of rubbish crafts that they can't give away, but they really enjoyed making them. And they found all sorts of things that don't correlate with the quality of the output, such as, like positive aging experiences don't correlate with how well grandma's pots are turning out. They correlate with whether she's doing that practice daily. So yeah, there's totally very different goals. There's very different patterns. If you're just trying to get better, like 3D printed objects, there's a field for that. There's also, all of games for autotelic experiences. Autotelic is a useful word that means for its own purpose.
So, in response to what you said about casual creativity, I still feel like, even though it's not a professional level of art in one of those casual creations, it's still pretty important to have some level of quality in the kind of product you produce. Like when you talk about games like Minecraft, you could have or Dwarf Fortress, you could have really elaborate creations that the user could really feel proud of. Whereas if you're doing some craft that produces crappy products, then you go through the motions of doing a craft and you enjoy it, but you don't want to do it, or not many times.
This is very much an idiosyncrasy of people, right? I mean, so your viewpoint is probably very much your own personal viewpoint, maybe, of crafting. There are other people who simply don't share it.
The Spirograph sells lots of Spirograph.
Well, no, I mean, I'll take like the most ridiculous example I can think of. I've never paid. Just bear with me. I've never paid to watch children play pretend, right? I've never paid for that experience. It's super, I don't want to be bothered with it. It's not very interesting. It's not especially Shakespearean, or Chris Nolan-ian. But they love doing it. The output has nothing to do with really anything. It's about the experience of being in that moment and making it within that social context.
I agree, but on more macro context, you can play Minecraft for 15 years and still enjoy it, while children do grow out of it.
I think children are playing pretend all over the world every moment.
No, but they grow up and they start
Sure.
enjoying pretend.
Sure, but when you think about building systems, we build them for all, like for presumably, different ages that's come up in different foci on like creative outputs, like whether I just want to screw around. Like a lot of people here probably in this room have doodled this morning and are going to sell it, but they still went through the action and they'll probably go through it again. They'll probably doodle again. Who here will doodle again? Matthew will doodle again, right? So, I mean, like,
But the question is, the question would almost pose to your embroidery project, because there is craft that is therapeutic, where the therapy for me is what it is about, and you can do this for like your life, right? There's no defined outcome. There might be, if you do yoga for your life, your body might probably get healthier, but it's also about another thing. I don't know whether it's creative anymore, but
that crosses the line from your craft, your casual creations have some value in themselves, even though that value may be small, whereas there are truly crafty creations.
Yes, I think maybe the center point is that it's not about the sort of like global level of quality. It's surprising yourself with how much better things are than you thought. So I found kind of a superpower in my generative work is if I add symmetry to something. So I've made a drawing tool that you draw and then it 3D prints the drawing. That was based on one that I saw in a shop where there were in fact some elderly people who refused to use the iPad thing to draw a smiley face that would get 3D printed out because they thought they were bad at drawing. So I fixed that by saying, okay, whatever gesture you do, it's almost like April's Blackboard generator, it multiplies that around. And so as I'm drawing, you see the arms coming out. And I can literally close my eyes and draw a really beautiful pendant. And it's not that my line was good. It's that the system has multiplied my effort and turned that into something that is better than my gesture was. So, I'm playing pretend, and this cardboard box is greater than this cardboard box can be.
it's a transformer.
So
Also, it's not just why you need to argue that one is better than the other. I think they both coexist.
Because I felt like the discussion on the other side.
Let me finish. I think they coexist. I think the experience, rating the experience and rating the product are both important in a co-creative system. And for each individual, whether it's for professional outcome or casual creativity, might have different parts on the slider of what's important to them. But I don't think it's only about product, and if the experience is good, then that's a bonus. And it's not only about the experience, and if the product is good, that's a bonus. I think you're on sliders on both of those criteria. And I honestly think that in the studies that people have done, not your personal view, but studies of many, many people, that it's very individual where you are on those sliders, what's important to you. And so the systems we build should accommodate both kinds of people.
Yeah, actually that was what I was saying. I was just, the discussion earlier seemed to focus solely on the experience of that.
There are systems which should only focus,
I think it's interesting that the two meet, right? For example, in embroidery craft and mathematical logics, like one could literally be, you do this while you watch television and it's something that is something for you, but how does the computational system relate to that and build on top of this? That's why I thought it was so interesting to see what came out of the work at Santa Cruz, right? So I think your question is, there is like the balance, and these two things meet and kind of not always merge. And I think that's interesting to see how, for example, this project deals with it. But there's no definitive position on that slide. They'll always move.
I think they're orthogonal. They're perhaps not oppositional. You can have a hard to use, unpleasant system that's also really hard to make good objects with.
Yeah.
and for something like this for Creature Creator, you could have something like that was very pleasurable to use, that people also made things, and Minecraft as well, that like pleasurable to use, and you feel like you're making something that is good. But there's the full vector space around that, some of which we'd like to be in, and some of which we would not like to be in.
Just, I would add even more dimensions. So for instance, in the work Andrea will be presenting, it's not about what you do during the co-creation process, it's about how it transforms you. In this case, we work with kids, and it's more, you can have a crappy product, you can have a crappy experience, but then in the end, oh, I learn how to do this. So it's very reductionist to see it only on those two dimensions.
And I can add another one that I worked on the Google Home briefly, doing prototyping, and I was trying to make casual creativity systems where you were sort of mixed initiative creativity systems where you're playing with the chatbot. Hopefully that you had a good experience, certainly not that you made anything of value, but that you ended up liking and trusting the bot more in the way that we often see people collaborate just by building IKEA furniture. They like each other better by the end, or they divorce. It's kind of awesome.
Well, to add on this one, it could also develop social connections, right? Sometimes you build friends by doing this, and your object and your process might be horrible, but you got anybody. So yeah, you can add and add and add to the richness of that. Can I get food?
To be 9 minutes early, to be fair. Any other final questions or comments? Please.
Just for the applications part, that I was wondering that how would you build reflection to your computer part to actually take into account what the user is doing? Any ideas about that?
So explainability, you mean?
Yeah, reflection, let's say that what I'm doing and how it's actually working on.
Do you mean reflection, or do you mean reinforcement? Do you mean reinforcing the system that they did something good, or do you mean?
Well, reflection that the system itself looks at itself, has an attention about itself and how it's right now working.
Do you know the concept of like the SimCity effect? The SimCity effect, it's a theory by Noah Werder, which is our advisor, or one of our advisors. But the idea is that you have a system that is an AI that you're interacting with, and you know enough about that system to be able to form, I think the phrase that I like is actionable hypotheses. So in SimCity, I don't actually know how the AI of SimCity is working, but it's told me enough about itself, often fictionally, that I can then make hypotheses about if I put a firehouse here, it'll do this thing. So I think it's not necessarily about the computer telling us precisely what's going on. So an AI system, maybe not that it gives me the output of its neural network, but it gives me enough fiction that I can make an actual hypothesis and then test that.
No, I was talking about how the system has a reflection about itself.
Yeah, so it's the other.
How the system is communicating with the user about what it's doing.
I've been wondering if this topic was going to come up. Right, because I think one of the interestingest things that we're not touching on at all is two people collaborating and arguing, right? So, oh, why are you doing it this way? Well, what do you mean I'm doing it this way? I want to do it this way. Well, that's a stupid idea. But like you can imagine having a conversation like that if you're collaborating with anybody, especially if you're good friends with them. And that ability is presumes even the ability to understand and know what you did beforehand as an intelligent agent. So I don't know if
in the area of AI and cognitive systems, there's something called metacognition, and that is your ability to think about what you're thinking about. And so I think a lot of the co-creative systems that we've developed that use AI haven't yet expanded into that metacognitive area. I know about it because I wrote a paper about metacognition and creativity, and it used a reflection on the cognitive processes itself to look for specifically novelty and surprise, and then to follow those paths as it was doing its generative processes. But that's a model of the model of thinking that allows that reflection. I didn't see it in any of these. Humans do it sort of interchangeably. They're thinking and then they're thinking about their thinking sort of all the time. It's hard to even separate them. but our computational models tend only to do the cognitive parts, not the metacognitive.
In the symbolic systems world, like Mike Van Lent did explainable AI as a term. So there's been some.
I just haven't
Yeah.
seen it in the
Yeah.
creativity.
Yeah.
The computations.
One more comment.
So, would you think that hierarchical models are able to do this sort of thing, such as like deep learning with adversarial losses that can simulate multiple functions based on some function of time during the interaction?
But they're not. They have to be able to report back what the features were that they learned.
Right, so it needs to be able to reflect or to have a level of, it's really thinking about thinking. So
At a human communicable level.
You've described how it does its modeling. Now, could you imagine a learner or something on top of that was able to learn about the learning? That would be the metacognitive.
So learning to learn.
Yes, or learn, reasoning about.
One last one really quick, yes?
Isn't this what co-evolutionary systems basically do? So that's one of the ideas. If you have co-evolutionary system, give, for example, a deep neural network, and you give another system learning basically the changes of the neural network, and it's basically a model description of what the system is trying to achieve, and it is basically a meta model, which is really hard. So that's one of the things which is really bad. It can't express it in a human understandable way.
Right. That's
entirely missing, yeah, because that's a really important bit. If you can't argue if you can't express yourself. So if you have a meta model, you still need to express it, and that's what I've seen recently.
Well, you just throw lots of examples of argument
Yeah,
in the system, and
everywhere.
then it'll clearly know how to do it. It sounds like the other group is out. Why don't we go ahead and break for lunch? Is it here? Is lunch being provided? There we go. And everyone, just please try to be back by 1:25, 1:30, and we'll get started with the game session.
Gabriella Barros will be heading that session.
Okay.
If people are worried about me
very scared.
being ahead of, okay, great.
We know we have to go to the games. We're not ready.
2 years after graduating.
Wow. Really?
Yeah.
Excuse me, everybody. I've got a random captive audience, I think, but I just wanted to let everyone know that all I wanted to just tell you see the website, but just so everybody knows, it's at the Manor Gallery, and that's downtown. It's 91 Broad Street. If you haven't bought a ticket, that's fine. There's a cash store. Cartel, who are working with us for the concert tonight. And do bring cash, even if you have bought a ticket. See you there. Sorry to interrupt. Thanks for your time and enjoy the rest of your workshop. Question?
If we have all the tickets with the concert, where are our tickets?
Yes.
Oh, sorry. Yeah. Turn up and we'll find them.
It would start at 7 p.m. exactly, or?
Another good question. Music starts at 8, doors at 7.
Okay.
Yeah.
Yeah. That we can all
To go together down by your own way.
we could make them happen. That's what people want to do. So
Yeah. Just if people want to make plans with groups, then they should just do it locally. Yeah. Okay. Thanks for your time. Here we go.
Okay, so hello everyone. Let's start the session, the third session today. It's going to be game related mostly. New York University, and I'm going to be helping host. So the first talk, we're going to have 2 talks, each one 10 minutes, then a panel of 20 minutes. So the first talk is Cicero Computational Intelligent Collaborative Environment for Game and Level Design.
Hi, my name is Thiago. I'm from New York University. I am working with Professor. And I'm here to present Cicero. So first, game design tools. Probably these are the most popular. They have a long list of features. I know that you can't read all the features where you are. It's just to have an idea about how many features they have. They have features about programming, editing physics, networking, sound design, and so on. They have features about editing artificial intelligence, but it's mostly in-game AI, for example, pathfinding and NPC behaviors. Some tools that address this problem. For example, we have a lot of level that is specific for 2D platform games. Robosum, that is even more specific. You can just use it on the game Cut the Rope. Regional proposals. and syntax sketchbook. So these tools, despite the impressive results, they created a conflict because they are very narrow. So we have a conflict that is narrow. And this is it is developed on top of the video game description language and the general AI video game framework because it fits all simulation, roguelike, adventure, action. The GVG AI framework to by doing something in the user interface. Your actions are translated in VGDL code, and the framework combines this description, the level, and the so by using these agents, some features, for example, steps tool, the steps shows diagnosis about the how an agent or a human player explores the game design rule space of a game. We have also a mechanics recommender. For example, it is based on our work by Ray Schneiderman and Creative Sports Tools. In his classification of School of Creativity, it is like a situationalist tool. So the main goal with this mechanical recommender is to save a designer or a developer when he's facing something like creativity block. So it will pop up recommendation on the screen, and the designer he can pick up the mechanics that he wants to add on his game. And we also have the visualization system that brings the behaviors of all the game elements that you have in your game. And based on our literature review and our participation in main game AI conference, we think that CISO is the first effort to create general AI game design systems. It helps the designers and developers by enhance their judgmental capabilities because now they are working with amount of data and information about their own work that they didn't have before. And it has some limitations. For example, the games are very generic. If you are considered a game like games, like those developed for at the request system. And we still have a very primitive physics. It's entirely based on sprite overlapping. And that's it. Thank you.
We still have quite a bit of time to this pretty fast. So if anyone wants to, we have time for a couple of questions before the next one.
Yeah, that's very interesting. I really see your point that we need to generate that, or that it is designed to it and we apply to the wide variety of game genres. But what I'm wondering about is, what is your target audience for this tool? Because I would expect game designers, but I would expect that game designers want to work with a tool which they could also, not like a prototype, because probably a tool which they could use to write a game model process, not like Unity, for instance, which of course is much more complex, but is transferring the lessons learned this to do something like Unity. Is that probably a special?
That's about the target audience. Yes, it is game designers and developers. So this is a prototype, and as you said, Unity is much more complex than system. However, Unity doesn't have agent support. You can split your games or even your prototype units with intelligent agents. So this is the goal, is to create a prototype tool with these many AI. And when they are satisfied enough with the prototype, they can get it and export to another platform like Unity or Real.
Okay, so maybe one more. Now we have visual procedural content generation with an artificial abstract art.
Gabrielle, myself, and Amy Hoover were the co-organizers for the Computational Creativity in Games workshop. So I wanted to take just a brief moment while I wish this folks at the illustration workshop for vamped for enough time. No, maybe. Pink. Okay, great. Okay, cool. So yes, that's the whole title once again. I'm Matthew for Caspian and Jack Doss put together this little project. So let's talk about automatic content generation. Thankfully, the very last talk brought this up a little bit. Create content from algorithms. We're pretty good at it these days. Note that I have an asterisk next to we're reasonably good at it, by which I mean for certain domains. So game levels like the one we were trying to appeal to novices for visual generation or illustration. And to be able to have a system that could create game visuals, especially for novices, this system would have aesthetic intention from developers, by which we mean it would need to understand some level of natural that the system would have some understanding of how to make okay. So some quick background in terms of where we are right now to get folks up to speed. In terms of most game content that is generated in terms of visuals right now, the number one thing is 3D textures. It is focused on one aesthetic, that being photorealism, and one visual component, that is 3D textures. There are some side pieces off of this, but this is sort of the main thrust of this work. In general, I should also note that the graphics community is very into this question of sort of how do you generate realistic textures. In terms of other sorts of visuals in games, there's not a lot of examples. I threw two up here, which are sort of representative. So either you have something like Margaret Johnson's Ultimate Ratio Regium, which basically uses some level of sort of visual PCDG to generate all the game characters in the game world, but it's all sort of one aesthetic. It's all sort of heavily designed and authored. Or you have something like Mike Cook's Angelina. I don't know which version of Angelina this was, 4 or 5 or something, where it actually just takes in images that it sort of scrapes online and throws those into the game. So not really generating here, but sort of some understanding of aesthetic intention is in play. In terms of things that are not games, but do things that are similar to what I'm going to pitch today, you have systems like the Painting Fool and a variety of other similar systems that are based on creating 2D art, generally from sort of imbuing the designer's artistic intentions or beliefs within a artificial agent. You have things like visual information vases, which does something similar to our system in terms of taking inspiration from other images and sort of doing something with them. In this case, generating vases. You have things like Darcy, which, like our system, can do some level of understanding of natural language. So in this case, Darcy was making this image more cold. All right, so what I'm going to propose here, or suggest here, or present here in theory is something that we're calling Polite, which is really just for the joke. Pollock Light. We are nowhere trying to be like Jackson Pollock. General outline of the rest of this talk, going to go over a brief system overview, case studies that I possibly can get through in the time. I thought I had 20 minutes instead of 10. In terms of our system overview, we focused on abstract artists because they run down into representation. Specifically, we looked at these three artists. We ended up creating this. Here is that artists have life experiences that has various visual stimuli that sort of gets tagged to these life experiences. This goes into some knowledge base that links feelings and concepts to shapes and colors. And then during the process of creation, you have the process going through the artist going through an iterative process of observing the canvas, imagining alternatives to the current canvas, executing on one of those alternatives, by or about abstract artists. More details on that on paper. To break this down a little bit more, what we mean is that prior experience, so like seeing these images and feeling joyful, ends up getting linked in our minds to, oh, these sort of creating an abstract painting. We have some initial canvas, it's just a blank one. We sort of imagine what could go on this canvas. We pick out whichever one of them is the most happier, the most joyful. This is with deep neural networks, specifically a convolutional neural network, which is going to learn features of real-world photographs based on and a fully connected sort of simple deep neural network for learning palettes in much the same way. And more details in the paper. We're going to be making use of Ekman's 6 emotions theory just because it is popular. Related to each of the emotions, these emotion tags from Flickr. So these are things that are just tagged by whoever uploaded the image to Flickr originally, for a total of 6,000 image versions. So that's fun. But it's nice to have some notion of how well it actually does, and here's some numbers which hopefully do that. So here, this is a very initial test. We had a fairly small knowledge, fairly small training set, but we actually have some pretty okay values here. I'll note that all of the sort of performances here, this was on testing our system on 100 novel images of each emotion tag. All of the emotion tags did but otherwise, it does pretty well. This indicates that it learned something from the images that it got and some predictive features. And so we did some case studies. So the first thing that we wanted to do, sort of similar to actually the last thing, the objective evaluation, was looking at 7 games that are up here along the top. I won't walk through each one because there isn't really time to do that. But we did a Google image search for each one. downloaded the top 10 screenshots for each game, the most popular ones, which we took to be the most representative. We had our system rate each according to how much it activated each emotional tag. And we could then rank each game according to, was it the most disgusting, the least disgusting, the most joyful, the least joyful. So in a table, which is not super exciting or super good for a presentation. But in general, we were pretty happy with these. So, for example, Bloodborne, which is sort of this horror game, gets the first place for disgust. Doom gets the first place for anger. Fear goes to Mobile Strike, which is sort of this Call of Duty-esque game that was sad. Which feels close-ish to right. There's some sorts of truths going on there. But the other thing specifically game content. So these would just be of the same sort of 3D texture generation, but now we're not dealing in photorealism, but sort of abstract art. So how you did this 5 times with each target emoji. Final output for each emotion, and we got these. So these are from left to right. We've got anger, disgust, fear, joy, sadness, and surprise. And obviously, this is a hugely but you know, surprise kind of looks like confetti, which is a nice effect. Sadness is sort of this blue sort of weighing down at the bottom of the canvas. Disgust, you can't really tell because they're washed out because of this sort of greens and splashes of color in between. We're fairly happy with them. It was alteration. So essentially, we took the same structure as we did for the generation case study, where we passed in this and had a the canvas we passed in was some game visuals, some existing game visuals. So this is a quick example. The right is the background for a Legend of Zelda game, I believe Link to the Past or Link's Awakening. Thank you. Right, your far right is a I don't have the name on me, sorry, it's in the paper, but trying to do sort of a dark of it. And there in the center is our systems take trying to make it more angry. And so obviously it's not a one-to-one thing, but in terms of some of the choices made, sort of deepening the shadows, changing up the house to have sort of a grittier look to it, it did a sort of reasonable job, we would say. Again, these are all subjective. The objective thing was way at the top. Through the Super Mario World graphics specifically, these are actually from the Infinite Mario engine because it's open source. So at the top we have the default appearance, what this would normally look like. The Goombas end up getting these sort of blue little eyebrows that are fun. This second from the bottom one is joy, so it sort of looks like this Easter sort of spread, which is pleasing. And this last one down here at the bottom is surprise. I quite like these pink polka dots that it added to the background there. And last, so my co-authors wanted me to show you Mario's disgust. It wasn't in the actual paper because I haven't been cut off yet. Oh no, I have to stop now? Darn it. Well, I won't keep going then. Just click through these. That's me. You can go harass me later and see those last few slides.
Maybe we each can have one question for Matthew before I start the panel.
Firstly, that's a really, really interesting piece of work.
Oh, thanks.
I got a bit tied up with the Ekman stuff, the
Yeah.
Ekman theory of emotions, because Ekman looked at emotions and how they related to facial expressions Whereas with abstract art, you are moving completely away from facial
100%
expression.
true, yeah.
So how would you justify choosing Ekman?
It's a nice set of 6 words. They don't overlap too much. And they're easily Googleable with lots of results. It's really just that. We could have, so in our early testing, what I didn't get a chance to show you, and harmony as our testing tags. We could have used any set of tags. We just had to pick something that was sort of reasonably got at what we wanted to get at. But no, we're not making any suggestion that these are like appropriate final tags to use.
You, perhaps the speakers like to go from now so they can start the panel. We have 20 minutes for questions and discussions, and please, otherwise I'll start. So about Cicero, you mentioned that there's a distinction between narrow AI and general AI BCG. And I see how VGDL is a general AI in the sense that it's more suited for general AI in the sense that it is generating itself, even though it's only 2D games on there. General, because it is specific in the way that you're doing that only for VGDL. It's not applicable to any kind of game yet. So in what sense it is general?
It's general related to those other things. Because, for example, if you talk about Wilson is very specific. Because Cicero, you can many kinds of puzzles. Other agents.
So, Kate.
I mean, it's language developed as part of originally mostly for testing AI algorithms through general opinion based. And the nice thing is that it's formalized and pretty simple description. Sorry. But basically that there are lots of games that are not representable by HDL. What would you say? How far can you take this? How far can you extend this in practice?
For example, those other applications like Tomato and both sides. The results are very impressive, but they are very limited. And I don't see if you can use these tools to expand them and generate new kinds of visualizations or even a recommender system. Because the nature of the application is completely different.
I mean, I often general gameplay because is general. And the things which do, often it's not capturing the cat collecting game. You could have an AI system that tells does not speak to me. And it should
design tool that should speak to everybody in this group because it can be a general game design problem. Or collision mechanics. It may be great, but it's not applicable to my style of game. Outside of this, but
I agree. I agree that basically it's enormously huge, and there's so many things we can never really. Sorry, I wasn't meant to answer that. Sorry, things spinning over. But I think the word general is always relative. I mean, things are more or less relative. If we always go for images in general, that's sort of trying to do.
I really like the work presented on HoloLens, both from the context of general context free images or whatever context, because there will be at the same time like other things, and how they interact is maybe more important than actually them individually. So I don't know. Is how
Interesting one is that workshop. And so there's an understanding that there is a human in the loop. And so for these both pieces of your question that you could, again, the easy and uninteresting answer is just have a human do it. Humans are good at understanding how another human will see a sequence of things. AI isn't very good at that right now.
Here's a follow-up question to that, because I know we have somebody in the room that's working on creating an AI system tool working with, rather than a human to then build it. How can you respond to that?
So I think if you had any AI system working with either of these two sort of co-creative things that we've brought up so far, you still need to have some human intelligence baked in. Like if we're talking about a heuristic, for example, for like what players that the human has authored. But you need to have some notion of what are these two AIs aiming for, right? Space and end up with anything that anybody would want.
Okay, maybe I get lost in the thread, but I'm glad you bring the because, for example, in my case, Cicero is a mixed human and machines working together to create video games. And I think the best metaphor to is synthesizers, the music synthesizers, because when they came out with those keyboards like for Yamaha, it is actually music created by human and computers. Yes.
So track, I was going to switch track a little bit. So if you're still in this.
From actually working as an AI assisted system, actually being useful in the
you know, you can always have things that are relatively more and less useful. Speed tree exists. I showed a screenshot of it, and people are using it right now. Texture generation stuff exists. People are using it right now. So it's not a question of when will we get there. We're there. It's just that we may want to have them do more things and have people use them more. And I Mike Cook's Dinesh system is getting there, where you're sort of making these things, and Kate's like, you know, the whole notion that you can run tracer without knowing any code, like I think is more the key than the human intelligence.
I was more asking. RPG components.
Sure. I think we're definitely getting closer. I mean, there's sort of pieces of this popping up, pieces of the answers to your question popping up, right? So you have stuff happening in supervised sort of AI happening in sort of deep neural network stuff that can let you do generative tasks much more easily than you could before, or at least sort of the expertise you have to put in to get something reasonable out. And I think that these things coming together, you can get, again, something relatively more useful relatively quickly.
And this ties a little bit in. When we look at the images that you're generating, that you're changing, the static, this is all based on a way that a person feels about the image. So someone with gameplay, what do you think would happen when you have that mixed with gameplay? If gameplay plays such an important part on how you perceive something. Very stupid with it, very silly. It might not be as
Problem for actual real games too. That, you know, if a big scary, you know, boss until it's dead, it's not really that scary anymore. So that this is something that is not sort of constrained to just something like this. But I do think the sort of underlying question of when you are experiencing these things, changed a lot. And I think that one of the big problems is we're not even currently turning on game stuff whatsoever. But to do something like you're describing, you need more knowledge from some. Maybe.
With your first picture, where you were displaying the 6 pictures of the actual graphical representation, can you talk about one more time?
I'm totally sure if you want to just send me an address or something.
cool. So if you have no more questions, let's give another thanks to. Okay, so now let's start the second part of the session. And the first work is a big applause for Q Cubus, a virtual sandbox to simulate ideas in children.
Hi, I'm Rajesh, and I'm here to present my master's thesis that I did with Carlos and my colleagues who can't be here. It's essentially a tool to stimulate creativity in children using autonomous behaviors. I'm going to start presenting a bit of motivation in the problem we intend to mitigate. In recent years, we've observed that despite creativity's importance, children's abilities seem to have slumped. We believe this to be a product of an excessively standardized educational model, and as such, we need to design. I'm sorry, I'm seeing a point. And additionally, it's very complicated for a teacher to create unstructured activities that engage entire classrooms. And as such, we designed a tool with an easy-to-start environment in which children can develop this type of activity. In our tool, we have a set of available agents that interact with each other and with the children during the context of a storytelling activity, which is then recorded as a stop-motion movie. We believe that it is important to evaluate and look at creativity in three ways during our work. Look at the creative process of the children, look at their creative product, and finally their creative abilities. Cubus runs on the tablet, and it's reliant on a touchscreen interface, and I'm going to be covering the system, but also the process that children used in the end to create their final movie. I'm going to start with the agents. So their purpose was to be the children's actors, and their autonomous contributions was what was supposed to stimulate children's Edmund's model. Interesting and coherent language to use. We can see here one of the ways that we used to personalize our agents was emotion color associations. And if we look at, for instance, anger, we can see in Cubus. Now, you may have, as a result of the co-design test, and so they used this shape successfully, so it worked perfectly, so we've kept it. Regarding the behaviors, so they also use color, but as I mentioned, with body movement and posture. To animate these behaviors, we used the Disney's principles of animation, of which I highlighted these four, some of which guide and capture and guide the viewer's attention. For this, we use primarily color, and others more the physicality of the actions that compose the behaviors, so we use postures. I'm sorry, the blinking always says within the agent's original hue, but it brings to brighter color if it's a positive emotion and the darker color if it's a negative emotion. On the other hand, talking about the movements, I should start to say that there are two sets of movements, and one is standard for a more moderate exhibition of the emotion, and one more intense for the more intense version. We believe that only one of them would be able to portray all kinds of interactions that children would see and do during the activity. An example of happiness, so here we can see a moderate happiness being displayed, followed by a display of a more intense version of the emotion in this case. Drive for the standard for the intense behavior. To cover them, so we see that in the beginning there's a random prefill value that's just to avoid having all agents fire at once. But after this, so the agents can receive two types of contributions to their drives. Goes up, it will act similar to here. It starts empty, and this is due to in the second step. We also have a time increase step, but it's make sure that the behavior is triggered by an interaction with another agent with the same emotion. So we wanted to keep that connection for the intense behavior, so the children could see visually a cause and effect. Again, when we and in this case, we use both drivers just to make the behavior simulate. We use and down to the social, which has less strong contributions. I'm going to show you an example. So here we see the able to affect the agent on its left. Now, if we put them inside the intimate range of the other agent, when it fires, it will, which will reciprocate. This is the case for agents with share of emotion. So we'll put it exactly in the same position. The intimate range, now we will see the agent on the left firing an unprompted behavior, so a moderate version, but when affecting the agent on its right, the agent on its right will trigger an intense behavior as a response. This was how this mechanic worked during the children's activity. Regarding the virtual environment, so it had a few responsibilities. One of them was the hardware. To give you an example, this is a screen or a menu where children could see the available agents, how to delete them, how to toggle their visibility and all that. They could also move them around, display within the virtual setting and orientate them in different ways to set up their scenes. To allow a bit more with different silhouettes to allow for different interpretations, and we complemented the personalization. So we can capture the entire screen or create an intertidal screen that has a written message that can convey more complex narratives. Here we can see an example where a capture was already taken and the children, for instance, see their progress throughout the storytelling activities, which is very important for them. Finally, I'll describe the process that creates. So it involves all the steps that I've mentioned to create the images, but some part of this is we see cues on the left where this happens, but then these images are exported to an editing application that converts them into a video and then allows children to record a voiceover with a narration or something that they like, and then this creates the final product. To conclude, how did we use this tool? So, but just short and sweet. So we insert children to use the tool to create a few movies in the end, and we analyze two versions of this element. Process the creative potential was compared, and after interacting with our autonomous agents, there was a condition where they didn't have these behaviors. This concludes my presentation. If anyone wants details of the studies that we've carried out, talk to you in person. Thank you.
Stands up. Okay, so this is the last presentation of the session. It is called VR Docs, a split VR tangible experience designed.
Hello, so my name is Pierce. Right. Colleagues that could present with us here today. Brian McGurko, Nicholas Davis, and help from other people on the arts practicum that we took place in here at Georgia Tech. So quick summary of the arts practicum. It's a split VR AR experience where one physical player walks around using HTC Vive and the Leap Motion to interact and touch with the objects that are created by the physical player using tangible objects.
So in order to virtual gap, we use a variety of technologies. Could be integrated with a lot of different technologies and also supports VR development out of the box, which was my choice. We're also using the HTC Vive. We chose that because its root scale technology was well suited for installation space. And lastly, on the virtual side, we are using the Leap Motion controller, which is actually mounted to the VR headset and is able to capture 3D and motion, position, rotate. Do this instead of using the Vive controllers because it supports more natural gesturing and interaction, and also eliminates the need for us to teach the user about how to use the actual. OpenCV, which is a library location of the tank. So first off, the project was specifically in our studio that we were in, which is creative trackers and sustainers when engaging. In this case, the trackers are concerned with gaining a participant's attention. So we wanted to really be inviting to outside viewers. Set up might be a little intimidating, especially to those who have never used the technology before. But we also wanted to use the naturalistic themes to convey the in-game feel and inviting. We also decorated entice passerbys to engage with the system.
We primarily relied on these tangible objects as the method of interaction with the table. Attached to particular locations in the game. Suggestions of what sorts of objects it would create, what sorts of combinations of objects could be created. So in the case of the two tangibles I'm holding right now, the moss object, musical, pleasant bush, should be a tree, etc. But have so you can see some of the trees and the taller objects will be generated by using a tall, physically tall. And on the left, you can see an example of the interactions that you can actually have on the virtual side. Because we're using the Leap Motion, we can track down the individual fingertips and position of the hand. So we can create a high fidelity mechanic where position, rotation, or fire off animations are set. We use this mechanic because we wanted to keep the interactions for the virtual player interesting and novel and compelling for the extent of the experience. So going through a quick walkthrough of the experience, we start people off in a sort of tutorial space where They need to interact with a single object in order to progress, which also gives them an opportunity to put on the headset and become familiarized with how you interact with things in VR, and the fact that you can actually users that we had in the art gallery weren't necessarily different technologies. So affording this time to interested in progressing. Into this sort of colorful, bright object to suggest that the act of touching an on, and we use the real about 3.5 minutes as a timer, so we can continually feed people through the experience. The object generation, the two of these tangibles are placed on the table below the webcam, tracks their position, and as long as they're within a certain distance from one another, it considers them having been made contact. At that point, an object is created in the VR realm. So both of these systems are interconnected and virtual player have to interact. Both of them need to work together and collaborate in order to reveal the full experience and the full spectacle of the system.
So we see this collaborative spectacle the physical and emotional response of the VR player. So like at first, the physical player does not know exactly what types of objects will spawn or how they'll behave when they use the tangibles. But once they start making sense of how the tangible combinations work, how the objects behave, and they will be interesting. This could be for the current experience or for successive experiences. This also means there'll be variability between each individual experience. You know, for example, one of our objects is a large sculpted stone head, which when the VR player touches, runs loudly and abruptly turns towards the VR player. And this was, you know, in every single case, surprising, very abrupt motion. Some of these, you know, some of the surprise was positive. Some of the, you know, people were a little scared of it. So as a physical player, you look at this, and you know, based on what your mindset is and how you think, you know, how you want the VR player to respond, you can spawn more of these heads for this person or other people, or decide not to do it, depending on, you know, how you like what your mindset is. So for future work, we can take like this application of this information asymmetry and concurrent interactions, apply it in other contexts. Dividing information in roles asymmetrically result in interesting experiences where each player relies on the other to fully understand the environment, especially if the interactions are split across different mediums. This could be in a context where one player is attempting to perform a task and the other player must supply them with the resources necessary. A building or construction game could fit this context where one player is aware of the high-level materials needed and the other player actually does the construction. And the inclusion of concurrent interactions, mainly in the context of like VR and physical experiences combined together, also adds to the engagement and forces each player to act and react in real time.
We also found this system interesting because it solves, or at least mitigates, one problem that the VR tends to come up with, which is information complexity and actually explaining that information to users, both learning how the control systems work and how these game controllers work, and also just conveying that information without the traditional paradigms of UIs. Game controllers tend to be foreign objects to a lot of different people. Our decision of pulling away some of that complexity and letting the primary strengths of the medium, the physicality, the movement, and the actual interaction with the body, way of interacting with VR, but also connecting that to a perhaps more traditional interface system, screen-based, something that people are more familiar with, could extend the amount of uses that VR could potentially have. Architectural visualization is one such area that we could imagine. You could have a system where particular facilitators, such as in our case, but that environment discussion between the facilitator and the person in VR.
So if you have one question for the panel? Yes?
Maybe I missed this, but how real time is it between the
Oh, so there are.
So I guess I mean between the VR and AR player, how is there any lag between?
Things together, and as soon as as soon as Unity detects that collision, the corresponding action happens in VR. So there's no, that's what we're talking about. No one has to wait for anything to happen. Do something and then look over and see how they react, and there's also looks like to them, and there's to the top-down view on the table.
A single game instance.
Right.
If anyone has any comments or questions, suggestions, I saw that.
I just kind of really enjoyed what you did. I think you mentioned in your wrap-up where there's not, you're not able to display all the information to the player, but I like how you designed around that and made the world filled with there's a series of experimental chess sets. Visual stimulus, it looks like a game in the one. There's one where it's dark spices, and you have to pick them up and sniff them to tell which piece is which. And then others where they were weighted in different ways, others which they made sounds in different ways. So I kind of like the creative. As a way to create surprise and increase in projectability.
That's really interesting. Only way to smell it.
So I quite liked the sort of theming of this sort of open, accessible demos of co-creation for the entirety of the panel. What do you think you gain from having this sort of more open and accessible sort of project, as opposed to it just being like this one-off thing? It's in a more public.
We intended to I'm not going to say solve that there, but mitigate a problem that happens in classrooms, and it's a real problem, and we wanted to make it a scalable solution, but also integrate, and I couldn't speak to as source social creativity in our work. And this involves having several children working for the same thing and have one shared creation involving their creative knowledge and their creative. It was important just for setting for several children and project their ideas to each other, and also receive stimuli from the system, but discuss the stimuli and then work with it and keeping the pace going just with the help of the system.
Receive artistic technology, so
technologies and a way that people might not necessarily expect or might not be used to seeing in a lot of different cases. A more touchy-feely video game in that sense is one that might not being able to interact with that and being able to interact with that in a way that feels welcoming and is suggesting that technology does a different idea and experiences or exhibits like that present those sorts of ideas to people.
And when you do something that is perceived as different, as in your case, you guys are mixing AR and VR in a way. How challenging it is to have to pass that first experience challenge.
Definitely, we definitely needed a facilitator. People don't necessarily assume there was a lot of cases where people didn't necessarily know exactly what the limits or the technology were. There were cases where people didn't necessarily know that they could lean down and look at the ground very closely or move up. And interactions, that would probably be the next challenge or the next facilitator, but especially inside of the table as well, because in the same sense, obscuring or including the AR technology or the AR tracker. And that's something we have to teach people, unfortunately.
And in the case of working with children usually nowadays they have a lot of they easier than an adult, which is interesting because it's their children. And you're doing something that is supposed to stimulate how their ideas come by, stimulate a narrative that is not here because they're just working with cubes. So how for them to get engaged into it?
The initial version was that there was a bit of barrier in that we had to break, that they had to place our activity in the creation of stop motion movie. What is a stop motion movie? As we explained, and all that. So there were some issues with that, but they were very comfortable in using in part why we picked them. So we wanted something that was very accessible for children and something that made sense. It was very cumbersome, like practical even for sharing, which is very lean over and just touch the agents and move them around. But still, we did have to have a significant part of our 1 hour sessions that was just basically telling them the techniques, telling them where the menus are, how they work, what they do. So that's why we essentially removed some of the features, but yes, that couldn't be avoided entirely. But after just 20 minutes, we started getting along.
We have time for a couple more questions.
So, how I'm seeing this right now, there's Cubist, which can be a good children's learning environment, and then we have the VR gods where we have the AR, VR, and natural reality working together. Anybody in the whole audience wants to comment on this? How can we kind of put those together where we now have a teacher working within a child's space and a space to actually then facilitate a better educational system? Maybe if I say it wrong. I don't know, that's what I'm seeing. You have a very non-judgmental space for children to work within to not have any natural psychological biases that will appear. However, you can now still work within our natural reality, but take away all of the psychological judgment biases. Is there any way?
See a little bit of this before. And one of the things that we made sure to have was positive acknowledgement of whatever you did. And this wasn't actually linked to anything, so it was like sort of ultimately non-judgmental. But we saw a very, very positive boost from that. People being more playful and more experimental when there was a really dim AI just nodding and grading along with whatever you did. So I can see like one interesting thing that co-creativity could do is
I guess that's what I'm saying, though, because it still has the AI involved and it still doesn't have, maybe I'm misinterpreting. If we have the VR gods to play, now we don't have space, we still have the natural human psychology.
I just remember it now that I told you. You said we have all these cubes there to not bias.
Yeah, therefore, it was their shows in China was a cube just to not getting bias.
So I have a completely different project that would generate game mechanic. We will play the game. Everyone different game mechanic. And then we ask them what's the story. And we also shows essentially cubes and rectangles for everything because we thought that was the least biasing. But one thing we found was that actually these straight lines and the cube shapes kept influencing the stories we got about what the narrative was in game, which was like not what we wanted, but it kept coming back, and it turns out that just had but like, oh, it feels cold, metallic, it feels sci-fi, it feels built up, it feels non-natural, it feels lonely. It's all or if it's a stuck there, something like this. So I mean, one interesting suggestion we got, we presented a paper the other way around. Instead, I mean, it could be was testing not instead of having like reporting neutral because nothing is neutral, like go for some extreme theming. It's all like high fantasy or something like that. So because then at least you have a share and sort of understanding of what these things were first.
I can confirm that there is some, if minded, that there is some bias. I mean, some children look at the cube and say that it was Spider-Man. This really happens. So they have that ability to just separate completely. But some others, while using it, so I've said that there were two versions being used, and one didn't have the behavior, so it didn't move it. They were all just cubes. And in this we have in this version with no behaviors, children did at times look at the cube. Oh, if we pick the smaller one and use it, I don't know, as a chess or as a table, they would use it as an object for that. So without the behaviors, I can see what you're saying, that they have some physical properties because everything has to have a physical representation. They will make some associations regarding that.
I'm not saying you did wrong.
No, yeah, I'm just adding to the. I'm just trying.
To come back to your question, kind of just like hanging over it. It's an answer to this also. I think there's no neutral word to be created, but let's say right? So there's no. How does that mean? So we don't complete that with projects on spatial cognition. In VR, we have the interfaces.
And one of the interesting bits there is that you can take away as many other stimuli as you want, which you always have in the other spaces. So it's a how does the VR relate to the R space where you would have external light, close windows, some air conditioning, and the most one, and what can you take away in the VR world, and how can you use this for an optimized testing condition? So I think that's one of the things that we get out of that, which doesn't mean it's neutral, completely not, but it's a bit more specified for maybe teacher-student question like that. So I see a possibility there.
Just a follow-up. If you take tons of with an focus primate, then you basically bring in some orientation into the entire space, which basically where you don't know what the cube will be like. If you basically prime the scenario initially, saying that this is a then you basically get a neutral space, which is the same when you remove a room like the AC and the lights. That's perfect. And if you then bring in some priming, then you basically can set up a really nice experimental setting. So I think this is a strength which VR and AR can bring in. They basically remove priming to basically do work, which I think the cubes are perfectly fine for that. If you combine it with some priming random environmental things. Yeah.
Later similar experiment with like the animated autonomous driving animated things. So it's like if your cubes are non-reactive, not like you need to have some sort of primate. But as soon as you get any sort of illusion of life, illusion of life is well named because with very little it gives you a lot. So as soon as if I have a cup and I don't have to tell a story about it, but as soon as I reach out for it, it skitters away. That amount of AI tells that story, and I don't have to talk about the cup is here.
Basically, any basic behavior you interpret, and you can basically strengthen it as well. If you have like then we're basically a theory of mind or some conceptual shared space where you basically model something.
It doesn't have to be like if you have, like if it's VR and you reach out, then you break it, the illusion. But if you have like a haptic feedback that relates to what you would expect, we talked a bit about expectations of the brain, right? So if you have something that keeps the expectation alive, then you don't need to build a necessary. Really, they don't what they're doing. At least they kind of have some kind of coherent behavior. It does not necessarily have to be narrative, but coherent and
There's many ways to be narrative aside from explicit.
Yeah. Whatever I mean.
All for participating. Let's give another round of
One other guy.
Okay, if everybody's of the workshop, and this is the part of the workshop where we kind of reflect on what we heard. We try and decide and where we go from here. I thought it would be useful if we were guided a little bit by the questions that are in the agenda, also by your reflections and your own ideas. I've created a Google together and then make that available to people afterwards as some notes or some reflection on what we talked about. I'd love to be able to share this with you so that people can take it in. Link. Does anyone know how to actually share part? You can put it in the URL. Share. First option. And then this is the link. I don't, is this going to let me do it? I think you just want to go to bit, not LY. Yeah, I tried to do a case. I'm just going to come back here. I'll put it at the top of the document. So it's HTTP bit. Capital J, DOZS. Okay, I'm just going to leave it there so you can. So the purpose of this workshop is to start up this community around co-creation or co-creativity. One of the issues is that most of the things that we talk about are very specific to the context in which the co-creation is occurring, as we can see from the games people, that the ideas around co-creativity in games don't look a whole lot like the ideas around co-creativity to actually share and have some common concepts, and that transfer from one context of use to another would actually sort of move us along in a direction a little bit faster than if we only talk to people who understood what we're talking about. So what we had in the ideas before the workshop got started was that we could try to articulate what we learned today. And this is just a starting point, but one is to understand computational one of three things,
but that its emphasis is on one of three things. There may be AI autonomous creativity in your co-creative systems. But that co-creative systems have elements of it and this AI-like autonomous creativity. And so that was really and sort of transcended the context of use. Who's being creative, in other words? Who is it? Is it human to human creativity? So now we're looking at co-creativity in the context of providing an environment where two humans are creating together. They're either drawing together or they're creating music together. And the system is somehow facilitating that. Human virtual agent creativity. A human and an agent sort of create together. And then there's social creativity environments, lots and lots of people, more than two. Some examples in the artists, where there's this sort of social creativity environment. And then there's human creative agents environments. And again, that's scaling up from just one human, one virtual agent, to many humans and many agents all creating. What kind of environment does that look like? And so those are some of the generalizations. I'm going to go through all this, and I'd like some ideas. And I see there's some people in here type anywhere, anytime. It really is our collective reflection on this, not some organized presentation. So then there was this idea that there might be a manifesto for co-creativity. What are the things that are common? Came up in papers that didn't get much discussion time. And the idea of generative models, whether they're cognitive or whether they're AI, the idea that co-creativity and co-creation means you're making something, you're generating something. And so that is sort of this basic concept that I think metacognition to recognize creativity is something that we talked about. We also talked about or encouragement. Is there a common language or representations for humans and agents, or do they just miscommunicate all over the place, and that's where the creativity comes out? Do we even need one, a common language or a common representation? And because we're talking about the potential for human and virtual agents, what are interaction has to encourage creativity? It can't just be interaction in the normal usability sense that we get in how do you make it more learnable? Those are the sort of basic creativity. And then main themes and research questions that define creativity was things that we can talk about. Should there be a foundation of digital games? Should it run a co-creativity workshop that is to make the papers from this workshop available on the ICCC site, because I refer back to them. Should be escalated into conference papers, or at least as a record for you guys to reach out to each other after an interesting paper and you want to that person. So now I'm going to leave it open and just see where people wander in terms of reflection I'm sure I missed something on the way from. Yep.
So during the break, we actually had an interesting sort of exchange about how we want to define status or role today. There was some desire to have a co-creative task with a human. As we were discussing, that seems to be a bit, at least for the present sort of level of artificial intelligence that we're capable of, a little fanciful, and a little hopeful maybe is a nicer way of saying that. So something maybe more like a symbiotic relationship where we have the things that a computer and AI is a fast search over a large database, large set of like possibility space exploration, in terms of evaluating out say procedures or structural ways of having organizing a co-creative system.
A master slave.
Sure, of course.
AI-based game design patterns. Work that I'm trying to work through, like, what are the AI can do with us? So not as another person, but AI is like the ocean wave you're surfing, like that you're surfing. So it's sort of environment. You still have behavior that you're navigating in some way. So AI is environment, AI is air, support structure, AI is force, AI is sort of so AI is slave is almost humanizing it too much.
Right, it's a
necessarily
tool.
need to go straight to these. And one of my all-time favorite quotes is asking if the machine can think is like asking if the submarine can swim. That we already have wonderfully alien AI. We need.
There's also temporary. It's simultaneous, and that means while I'm drawing or writing, is it drawing and writing at the same asynchronous? And I worked for a little while and run out of an idea. So I don't know, we haven't really, when we describe our work, we haven't really made it clear what is the temporality. Is this all going on at the same time, on the same palette, so to speak? Is there stuff running in the background before this? Okay.
To quote this comment in your comment, you're using the word co-creation instead of co-creativity, which I think is
co-creation. I put that up there because I think we often confuse co-creativity with co-creation. And so I put them both there. Co-creativity implies that the product is creative, not just it hasn't been made before. And so, and I'm never sure when I talk to people from other fields whether that's meaningful or not. I think in the area of music, the fact that you generated a piece of music is creative. But if you generated something that's highly derivative of Beethoven's Ninth Symphony, I wouldn't call it very creative. I would call it derivative. And in the area that I come from, design that one, I designed the one I'm saying is mine. And so there is a difference between things that are made and they're new, but they're not creative. Co-creation is the term that refers to the act of making something that didn't exist before. Co-creativity implies there's a little bit more to it than it didn't exist before. So I don't know, is everyone in here sort of buying?
Where the nature of the workshop should go. Creativity doesn't make a lot of sense, but if it's co-creation, that can go to all sorts of different sort of.
CSCW.
Yeah, sure.
Super collaborative work could be a co-creation workshop.
Right.
It's about making something.
Or a general AI conference, AAA.
Yeah, or an AI conference. That's right. So my interest is in the co-creativity. I'm very interested in what makes something creative in the sense of novel, surprising, unexpected, stands out. Frank Gehry building compared to this building, that sort of difference. But I appreciate that not everyone in the room has that same sensitivity. That's why I left it up there. General broader sense. It's a little, it is more narrow because I think co-creativity is also co-creation and not all co-creation is creativity. So let's hang on to both of them for a while because it doesn't make sense to eliminate portions of it. So, but, and I think even in this manifesto, these things that transcend, there's still
Preparation for creativity. I mean, it is a question of whether the overall process is able to watch creativity or not. But then you can also look at whether the actual AI system part is coded for that or not. So you could have, I think, one of the use cases we're envisioning is like the human, this is not. Things, which would yeah.
So the agent isn't necessarily being the creative one, you are the creative one. So that's, I think, a lot of literature on what makes a support tool creativity support tool instead of just a tool for making things. Some of them clearly encourage more creativity than others.
But I guess as we're starting out on this, rather than just say edge creativity included, because the actual process of creativity, the ability, the creative ability is included in that.
And what exactly is development? I mean, if we want to take it as deep as co-creation, create between maybe just a human and an AI, sorry, maybe this is very big, but a human
So novel, let's put that down as one of the research questions, because that certainly is a very significant research topic on what is novelty. The research question, and if you
maybe we can not hearing something right, but as a human now working with an AI or working with another human or anything, if proper communication is occurring, novelty can't really arise until we do take a full, say, AI system that with a, he doesn't take ability for the baby to basically removing all stigmas from them and not giving any bias.
So novelty, I think you're putting too much into novelty. Novelty arises from several sources. One is an unusual combination of concepts or ideas, and it's the emergent properties that are new by putting those two together. Even if you can recognize the two components as being somewhere else before, they were never together. I was watching Soundbreaking, the documentary on would not exist before we could record music, before we could write algorithms that could generate music that humans could not conceive of. And so I don't think I agree with you that there's nothing novel unless you're born in an empty space with nothing else happening to you. Sorts of conditions, combinatorics, new materials. If you look at Frank Gehry's buildings, because of technology, he was able to create building shapes that did not exist before, could not have existed before, because the technology was required to enable the forms to be.
And almost at that point, but at that point, it sounds like without the technology, the creative product could have never arisen. Now the article on that is creativity, not creation.
Maybe we are, and maybe that's something that's worth reflecting. When we look at some of the games that we're developing now, did the use of technology, as it did in music, change the design space for games? Did it make possible things that didn't exist before the technology was there? That'd be a really interesting research project to try and understand how technology has made games something that they couldn't have been otherwise.
One of the things that we talked about today was going what we're talking about creativity and what's creative for the individual, what's creative for society, and what's creative for the agent. I guess one of the things I'm wondering is, if something's creative for the agent, is that a step toward something else? Like, does that really matter in itself, or is that sort of just us taking steps toward an agent doing something that's creative for people or creative society?
Well, I don't think so. I think the difference between P creativity and H creativity is only the space in which you're generating the new idea. For historical creativity, it assumes that you have access to all of history in order to determine whether it's novel or not. If it's P creative, and I'm assuming my space of possibilities is what I've experienced.
Right, but we're defining something like that. When we're defining something like creativity, we're talking just about ourselves, right? We're not talking about something, I guess it could be creative for a computational agent. And I'm saying, is that worthwhile in any way at all, or is that a stepping stone for something
I don't know
else?
what people think, but I think the same mechanisms are in place, same processes. Combinatorics, emergent properties, the sort of things that make something novel can happen in a P creative space or an H creative space. And a lot of people who study creativity define their space.
and say in music, this is creative, in art, in paintings, in representational. So I don't know. I think it's still creative, even if it's only creative to me.
There's also application domain. I'm not sure it was already covered by the talk, and I would be particularly interested that the ability to create some artifact that interact with it, then you will feel key creative. So it's very interesting in the case of games. When people feel, oh, and they feel this key creative moment. So it's not about being creative while you actually, I mean, I don't know if you can do this without being creative actually, but designing something that will feel that people will feel creative while interacting with it, and maybe will also improve their skills, if I can call them skills, which is a different way to see. I don't know if this still is within co-creation, because you're kind of delaying co-creation for the final iteration. So it's not at the design stage, at the implementation stage. Suddenly you have co-creation during
Reminded of this morning when we were talking about a co-creative system's purpose could be to provide that creative experience, that satisfaction of having been creative. So I said, what is the value of co-creativity? Is it that experience, or is it the, is that what you're trying to say? Or I think you.
Implicit kind of co-creation, which is when people actually are experiencing what we produce rather than while we're designing and developing this same one.
Oh, I see.
So you feel
so
creative.
Experiencing a product, sort of like improv.
Yes.
Or the game, or a piece of music.
So actually interact.
Can you read that?
I can read it here, yeah. Yes.
Co-creativity is one of
maybe on the nature of goals and the interaction patterns that define co-creativity.
down here.
On the nature of goals, like
Goals?
is it goals?
Oh,
Is
goals,
it like a higher goal that they're trying to accomplish, or is it, for example, in Drawing Apprentice, we don't really care what the end artifact is, but on some different piece of software.
So do you want to give some examples of what might be a goal? So what I did is I turned it into a question. What is the goal of the co-creative system?
So you develop a nucleus activity. That is the point where it's off into a new, totally different activity. So how frequently do they change in the analysis? Like how much time do you invest in building that goal versus how frequently are you breaking these things?
Problem there. So the shifting deviation, I think, is a big question. Things differ from the beginning of a co-creative process up until the never-ending experience, right? And I think that's one of the things that kind of stuck out for me. That is a big problem. So if you answer what's one co-creative activity, that doesn't mean that it will be of any value 10 minutes down the line. And games are pretty good at that, for example, learning curves and stuff like this. Is stuff that might be something or a sport.
Right, so we need to track and design the dynamic process. Also to recognize that it's time to, in the design process, you get to a certain point and then you just change the right.
Maybe the stay alive. But I don't know how to present it.
Or some like which actions from the user would be most informative to know that this is his intention, his goal. So that he can. Well, can you repeat the question?
Like metacognitive models?
Cognitive models that share the same space, but when they're working on a similar goal.
But I wrote something down, so you can go edit it.
So remember I can define co-creation before we define co-creation. So what is co-creation? And what was the boundaries of co-creation?
Okay, go ahead.
Oh, that's
Co-creation is, do you want to finish that sentence? Just try, it doesn't have to be right. Co-creation is
The act of creating something that is novel.
I don't think we need novelty for co-creation. I think we would just say,
Is Microsoft Word
building our artifacts with a system with agencies.
Probably multi-agent systems that can.
Oh yeah, multiple action partners integrated. And then
I think active is probably for
That's just defining the code part. Still not defining the creativity.
okay. Now.
And now we're differentiating co-creation and co-creativity.
Something that
creation
does
doesn't
not
necessarily
exist.
that. It's just building an artifact.
So modern
So friend.
Okay, fix that. Co-creation is multiple partners engaged in a creative endeavor that generates something that did not exist before.
So it's a lot of active, I think multiple active partners, which I think is important, but maybe should not be less.
Microsoft, so Google Docs, is this a co-creative environment? I'm typing, you're typing, this document never existed before. Is this a co-creation environment? I think so. Not a very smart one. It's got no AI, but it's got a lot of affordances. I can see where you are, I can see where you're typing, I can look at the history, I can undo.
It needs to have procedural quality to it. So if we give Google Docs procedural quality, then it can.
Well, then you're assuming one of the partners is rather than just support.
Is software.
Yeah, totally. I mean, this area is procedural.
Well, it has a process that can join into the process to create something.
Doesn't apply the process when you create a document. You have to do it. It's shaping the space that you create.
Well, it has a limit to how far you actually take. Yes. Well, be taking two and taking some.
As does any tool and as does any tool.
Yep. Here is our third line. Yes.
Well, if you don't want to accept a Google Doc as a co-creation environment, then what is it about the definition that's missing? Are we assuming that the product is created, or is it just hasn't existed before? Are we assuming that one of the partners or the computer partner is intelligent?
The computer partner is not active. The computer partner is just left as less to do this.
And co-creation is not that.
I would say.
Okay, so do you like, if we put active, well, multiple that we're all active partners, you mean one of the partners is the computer? Active partners is the computer.
Is intentionality part of the path? Because there might be a difference.
I mean, if you're only going for the process without already intention, then intention to collaborate.
But to put it out there, Google is not intentional apart from making money. So therefore, Google Docs is not a partner in a co-creative process. Just to throw something.
Intentionality is essential for all.
Well, then sheer functionality. There you go.
Say that again?
So how do you identify intentionality? For example, in Google.
It's a good research question. We're not going to answer that one today, but I mean, people have tried to answer that. But that is a really good research question. Do you want to try and define intentionality?
No.
I mean, intentionality means that you have goals and that you're trying to achieve those goals. Or intentionality is that you have a preconceived notion of what makes something creative and you're trying to move in the direction of that.
So are you saying in this case intentionality would be trying to have a creative product? Is that?
Well, I would only put that in co-creativity. Here I would put that in co-creation that the agent should have either explicit or implicit goals, and that's its intent.
So for example, can we say that, for example, Google Doc here has the intention to help you create a doc completed?
The software has no concept of intentionality. It doesn't have goals.
So it will always be the agent who created it.
Right, so the intentionality was in the program.
Arguably,
I don't know. I think that there is a lot of early work in AI systems that generated paintings that had no intentionality. And it was the programmer who wrote the algorithm, and the algorithm generated the painting. And the question was the algorithm the creative entity, or was it the human who came up with this clever algorithm?
So was the intention with the human or not?
No, this was the example I'm talking about was an autonomous AI. There was no human.
So again, is intentionality to be inferred from as a black box, as observing the behavior, or to open the code to see if there is a model which implements it?
There's a variable called intentionality. I don't know. These are really good questions. Did you have something to add?
I just think it's difficult to say that a sort of agent that creates art because it has been told put a pixel here, then put a pixel here, then put a pixel here, is not co-creative or is not able to do
Autonomously
right, by saying that the intention is with the designer, because there's clearly, with any sort of AI technique that you would use right now to inform an agent, there is some intentionality in a human designer to start with, and that gets put into the agent in a variety of different ways. It's not always just actually writing code, but it's still the case that the intentionality is always with a human designer. It's just there's sometimes other things going on as well.
Well, there are AI systems that can reason about their goals and their intentionality. That part where we said you can shift goals, or goals can emerge. If the system's capable of reasoning at the level of goals, then it's generating its own intentionality. Yeah.
But I don't know, this is where my super in depth, but so was that input into the system in some way like, I don't know, meta intentional of the creator or its creative machine to then create? So again,
I see where the problem is, but I also see that it's different to just writing an algorithm that puts pixels on a piece of paper. It's got a little bit more reasoning, a little bit more of a cognitive model rather than an algorithm. And so it's different. Whether it's different enough, I don't know.
I think the question of whether the Google Doc is a co-creation is an interesting one, because it's used to set a lower bar. I'll posit that it's not, but perhaps like sending a text message might be, because there you have predictive text. And I think that the definition we have now is quite strong for talking about intentionality. But when you're sending a text message, you're generating a message and you have active assistance in the form of autocorrection, and you generate an artifact. Maybe that would be a useful lower bar to set on a co-creation system.
I love that. Anyone who sent a text message and it's auto-corrected for you, you have just experienced co-creation. And when it auto-corrects wrong, you swear at it because that's not what I said.
I mean, those systems can have bias and all kinds of other problems, which I think will be common themes to co-creation systems.
No, I agree. I think that's a really interesting sort of lower bar to set, and then we build on top of that. Yeah.
I think I find it very tricky to use the word intentionality in this context, because I think it's very strongly related to this idea of strong computational creativity in these areas. I don't know if we really want to impose this stance on co-creation, right? Or if we actually consider this to be some sort of weak computational creativity as well. I think one problem is whether we have a artificial system which follows its truly own goals or the goals of some designer to get the example before. I think it's probably totally legitimate for a co-creation system to follow the goals by some designer, as long as the other system contributes something which comes from goals which are not goals of the human counterpart, right? But I think softening this definition a bit, not using a notion of intentionality here, would allow to make a further distinction later on in the process between some sort of soft and strong co-creation, for instance. I think you have to be very cautious about just intentionality.
Well, how about I modified it? So if it's an AI-based co-creation system, then you would expect it to include the ability for the system to reason about intentionality and reflect. I added reflection. Intentionality is setting up your goals and doing something with purpose. And reflection is reflecting on it, saying, oh, that was creative, and oh, that was stupid. Right? So anyway, we could qualify it rather than.
So question here comes is, if it's intentionality, does it also need to have a reflective behavior on the creativity itself?
Well, I added reflection up there. So we have co-creation, which is standard vanilla, low bar. I send a text message, it gets auto-corrected. I have co-created that message with the computer. It even changed what I meant without checking with me, by the way. Just changed it. And then we have, do we want to call it AI-based co-creation as a distinction from just the vanilla Google Docs? You like that? You don't like that?
that feel better?
How they're feeling.
I mean, these are important, these are really hard questions. It's not like it's all out there, we're just saying what it is. We're sort of making it up as we go along to make these distinctions so that future research can then be informed by these distinctions.
I'd like to throw out a scenario to just think about intentionality. So in classical art, we have someone who commissions the art, and then we have the master of the art who actually controls the project, and we have the little apprentices who, the master may not even touch the painting or the sculpture that much with his own hand, but the design is involved in it. And the apprentices don't get to say anything, but they do the actual strokes and add material to the final product. So does the commissioner have intentionality? And does the apprentice have intentionality? Are they both co-creators in the project, or are either of them not creators in the project because
It might depend on context. So my experience has been across many different disciplines. And when you look at what an architect does, I was in an architecture school for 20 years. And say Frank Gehry or Frank Lloyd Wright or Renzo Piano, they produced amazingly unusual building designs. And they had a client, and they had the people that were doing the construction. They had all sorts of people commenting on the designs. But nobody would say Frank Gehry's building wasn't Frank Gehry. He's the one who was the creative agent. Everyone else was just giving ideas. But I think when you go into documents, writing stories or writing a research paper, we put multiple authors up there. We put the supervisor, we put the student, we put right? So we acknowledge anyone who has made a contribution that made a difference. But that doesn't happen in all areas of creativity or creation. So I think it depends. Even in design, look at all the stuff that Steve Jobs did that was influenced by all the people around him, but everybody still calls it his stuff. So it depends. But those are all people that you were referring to. I think the interesting question is when you start having an agent, an AI agent collaborating with you, design the next iPhone. That was that ownership issue. Who is the creator? Who's this?
I'm kind of interested at which point the AI agent must have understanding how low level it is about that some of its actions are interactions with some other agent, with human or other agents. Because I could write a function alter that would take an artifact and alter it, and I could call it, but repeatedly for the same function for the same agent, but the agent would know who would have made the artifact before. So it would know that it's interacting with anybody else.
Anybody want to comment on that? I think it comes back to the roles rather than AI having intentionality and reflection. That sounds like when we talked about what are the roles.
Yeah, I kind of put it there, that what is the minimal role of the agent? He called co-creating agent.
Anybody want to conjecture what that might be?
Let me pose the same question to you. Let me hear your thoughts on it. I would really would love that because to the point where we now have a human creator, whatever, telling this creative machine what to do. How far are we going to take it to the point where, okay, this is the absolute bare minimum 1, 2, 3 that this machine is able to work on?
Yeah, I kind of, that was my question, was there is the creative support tools, and where it comes to that the agent or the system is co-creating,
Yeah, where are we differentiating between the person who is creating the code and the code running as an AI code? That seems to be a very big reoccurring theme right here. We're still arguing all this minutes of it rather than, so at what point does the original program coder separate from the artificial intelligence code running itself? Well, what is that point?
If I may put my 2 cents, I will maybe reverse the problem and put it in the eye of the user of the system. Coming back to the idea of intentionality, I'm more familiar with, Daniel Dennett's intentional stance and the idea that, okay, maybe there is no real intentionality, but there is the illusion of intentionality. And if, as a user, you interact with this tool and can attribute this kind of behavior or characteristic to the system, maybe it's enough.
So I put up 2 questions. What is the minimum role of the agent to be called the co-creative agent? The range is the agent's responding to a request from the human agent, or the agent is contributing without being asked. Like those are the 2, right, the beginning and end. Then there's a lot of nuance. And then when is the agent just doing what it was programmed? And when is the agent being intentional?
And this applies vice versa to the human also in some sense, because we're talking about co-creativity.
Well, generally humans aren't programmed, but so I don't know how to get my head around that that part of it. In fact, it's impossible to program humans. Hard as you try. You give them instructions and say you must follow these instructions. No way, man. You can't.
So this is the question when a tool turns into an agent or not, right?
Say again?
Yeah, when a tool turns into an agent, I'm me personally with my advice, and I can't even comment on that because, again, that tool has been built by some creator. So in any way we really want to think of, there is still some form of intentionality. And so you do have, that would be amazing, but a creator who has absolutely no intentionality based on anything. So here's the question: why are they creating? Well, in my head, that's why would they even try to create if they have absolutely in no way any form of intentionality for their creation?
So you're saying intentionality is required for it to be called creative?
Not even fully required, but if we keep taking it back to the person who is creating the quote unquote machine to then build more, where does the intentionality stop? Because at some point, if we keep taking it back and back, that creator who created the machine in some way had some form of intentionality. If not, what was there?
I think it's not it's a valid question, but I think it should leave it as a question. How about that? I think that we're biting ourselves a bit too much into intentionality right now because you're other questions out there. So I think that it's
my point of co-creativity and co-creation at this point, trying to understand who's got the intention when really the intention's got to be at some point. If you can take intention out of
something to add to
awesome, but
Yeah, again, a question from the back channel chatter, but yeah, so we're kind of grappling on all this philosophy of intention. So it seems like a kind of common thing to do in ICCC. People come and present this really interesting work about design, and then we set all of that interesting work about design and how it affected people and the very specific techniques that we use to get that effect. And then talk about stuff that nobody tried to implement, or if they did try to implement, they haven't talked about it. Is there anything today that talked about intentionality? And that might suggest whether or not we think intentionality is actually that important or that attainable, or whether we have, what is talking about intentionality going to do for the work that shows up next year? Is anybody planning to spend the next year, taking some of these ideas about intentionality or about, what it means for us to treat AI as a person or not, and then bringing that in next year? And if not, maybe we should talk about the things that we are planning to bring in next year. What does it mean to do the sort of things that we're doing, but doing for another year?
Yeah, so the intentionality studies and manifesto, I think there is some sense in the AI community that agents should be able to reflect on it. Whether it's comment or being done here or talk about it in today, it is something that has been a topic of conversation at ICCC for many years. Because ICCC started out with just, not just, but its origins were writing programs that produced musical heat. And there was this question of, well, where's the creativity there? It's just following very precise instructions and can't vary from that at all. And so then it has been a topic. And in co-creativity, I think you can say, okay, we'll let all the intentionality be in the person, and that's fine. And not even mention it. You just assume it's there, and not worry about it. But it is, if co-creativity is to become part of the ICCC, it's going to acknowledge intentionality is an issue. But coming back to sort of what are the main themes and research questions, and how can this be a field? How can co-creativity be a field? It is probably more productive to focus on what we can do over the next year that they can then bring back to this community. So let's talk about that. Do you want that in like next step? Sounds really procedural.
Put it in red and say it's the real goal.
Okay. So. Okay. Any thoughts? Anyone want to try and say some of this based on your own work? Everybody had some future work there. Anything worth reporting that you think might generalize beyond your own specific paper?
I think goals should be to design systems which are actually employed by people outside our research community in industry, for instance.
Say that again.
I think to produce systems that are employed in industry, for instance, design game co-creative systems to design game levels which are actually used in game industry, which actually attract people's attention, which are actually used. Sorry. Could be like a iterative process over years, right?
So design systems that engage people outside the research team. Anyone else? What's a reasonable goal for this co-creation field? Think of your own work and then generalize.
I think outside of the AI focus and related to this, I think there's some value in looking at what kind of interaction paradigms work for co-creative systems. So how do you want to visualize your co-creative partner or see the kind of work that they're doing and vice versa? Are there patterns?
Explainability came up several times in discussions. So have an AI partner capable of explaining its intentionality to you.
I kind of like to see some of these concepts of creativity that we often talk about to use and not just implement it as a system. Sometimes we think of just implementing a system, like, okay, my system can self-reflect. But for somebody to bring in full loop and actually get something of value out of implementing one of those systems. So not just proving that a system can self-reflect, but saying, I got the system to self-reflect, and this is what that does to the system, or this is what results in that. I think projecting stuff out of the other side of something that conceptual one thing, but I think there's a lot of concepts involved. We talk about we should have one, but we don't know what we're getting out of the other side, and we're just gonna stop implementing. But don't get all the way around.
So I wrote co-created systems that generate something useful or valuable to society or to individuals. Is that captured, or would you say different?
Yeah, I guess it's the sort of ICCC of taking a concept from human creativity, like conceptual blending or self-reflection, implementing that in a system, and there should be a reason for implementing those in a system, not just to kind of check a box and do it. There's also like, just checking a box that we did it, that's actually really interesting as well. But I'd like to see like a circle at some point.
It sounds a little bit like the first one, science systems that engage people outside research. But yeah, I think it's, yeah. Anyone else, one of the goals for your project that would translate into something relevant to the field? It's not the one you're doing.
So one of the things we're working on is basically enhancing the creativity of the other part. So with the co-creative process, when you start off and you have somebody who has no idea of what they're actually going to do, the interest, what we are pursuing is basically supporting the discovery of what it means to be creative. And that's one of the things which we are basically trying to emphasize. Because the thing is, you start off and when you look at kids, young kids like age 7 to 11, which we had in one of our studies, they basically have no limit to what they're exploring. They just go crazy on all aspects. And then we have a transition in one of the papers, which is currently on this commission, where it's 7 to 11 and there's 11 to 14. And what you see is that basically the older the girls in our case, the less they basically explore the space. They're self-limiting the older they get. And that's one of the things where a co-creative system can actually help to basically widen the focus again. Basically show that there's potential in the space, which we've seen today in one of the papers as well. That there's potential to basically enrich somebody's creative process.
I think that's a really, really good reflection. I think it's probably what we're all very interested in doing when we build these systems, but like how you said it really well. So co-creative systems that enhance the creativity of the human part. Anyone else? Think about your own, yeah.
What about more discussion of sort of frameworks or the design space as a whole? And we all have been sort of thinking about our own individual contextual co-creative systems, or maybe discussion of, okay, so this is within this one small area of my own idea of the design space of co-creative systems as a whole, but that might be a different idea of the design space for somebody else, and more discussion of what we should do.
And that comes back to reflecting on all the stuff we put about, but thinking of it as a goal of something that we could do in the next year or so to at least put it out there so that people can criticize it or they can say where they are in that space.
Well, just talking about our struggle to make the distinction between co-creation and co-creativity and to define the concepts. Now, that actually reminds me of what I was struggling in the past 10 years to come up with some definition of creativity in general, right? At some point, I think some of us took this more liberal perspective and said maybe creativity is just an essentially cognitive concept, and we never get a consensus. People always go out about it. For some people to attribute creativity to someone else or a system, certain factors are more important than others. Now, I think it's less commonplace that someone attributes co-creativity to other systems than creativity, right? But maybe the same problem applies here, and maybe it would be interesting to do the same thing that we've been doing on creativity, do research, field experiments to find out what factors are important when people attribute co-creativity to the system. I don't get more clarity here. But my feeling is that creativity is just inherent in these definitions. Why don't you try to get a rich definition of co-creativity and co-creation if we are aware of these problems of creativity itself. Maybe one level of views support here, maybe it's important to consider this essentially cognizant concept as well. Maybe it would be interesting to analyze the factors in the diffusion of co-creativity.
There needs to be discussion this morning about product focus versus experience focus versus product focus is useful. I don't know where that fits in, but I think it's useful to think of the goals, what those silos might be, or what those types of evaluation.
Saying this very well. Someone can fix that. Anyone else? In your own research, the goal you have for the next year that you think would be useful for this community, you can start to get specific if it's just in your space. What's important in games? What's important in art? What are the big challenges that face you in moving to the next level or getting the next research grant? You don't have to give us the answer, just the question.
Something we don't have in our lab is we're not sure how to evaluate these systems because a lot of the evaluations are designed for product and utility-focused experiences. But at the same time, the experience-focused evaluations are often don't recognize the bigger product involved. So having some evaluations that both respects the product and respects the experience. We haven't found one that works really well for us. And certainly not one that works well for people reviewers.
So I wrote down, how do we evaluate co-creativity in a way that's different from other interactive systems? And acceptable to peer reviews. I think it's all sorts of ways.
We're trying to validate too.
Although if we could at least manage it in this community, that'd be one step, and then we review each other's papers. Anybody else? Yes.
I talked a lot about having parametric design kind of things where we have sliders where we can indicate to the creative agent what we want. And I'm wondering how the creative agent might do the same thing for us and tell us what it needs from us to be creative.
How's that?
Yeah, that's good.
Okay. Because we do often think about the human as being the one who benefits. What if we turned it around and thought, how can the creative agent benefit from us being there?
We have the personalization, so personal adaptation to users process. Personalized
Is that what you, did I write that all right? Personalized and also be adaptive to different users, like it should behave differently for me.
and through time also. And through time, because one thing, the same user can be, learning something and 10 years, in 1 year, and it should be adapted because the process will.
Okay, does everybody have their paper topic up there for next year? All right, next steps. Let's just take a few minutes for next steps. So I will make sure that the papers get up on the ICCC site. modified version of the Google Doc. I'll leave it here for anyone to edit on the IEEE site, ICCC website. Anything else? Does someone want to propose that there be a workshop like this at the next one, or do you want to propose another place to bring these same topics and issues? We want this to sort of generate a community around it. Could be a bigger community.
I guess related to that, I'm wondering if people have other examples of similar workshop communities. So like at CHI this year, I co-chaired an Exhibition of Creative Interfaces workshop where a lot of the conversation that I'm hearing here also happened in that space. I think there's value to having multiple workshops from multiple points of view, right? But I think it would also be good in terms of community formation that identifies where else people in publishing is kind of what we're talking about.
So I wrote down identify other communities and include co-creativity research. That's a really good idea. So we could have others to talk about what we do. Where do you go when you don't talk to us? You go to the games workshops, we go to ICCC, CNC, Creativity Recognition, CHI, GDC. Other next steps? Do you guys want to share your slides? Do anything mundane like that? Right. Well, I think we are winding down. People are starting to get quiet. So please feel free to go in here and if you write this down, or I can send it around to all of the people who attended. Go in here. Please feel free to edit this, add to it, clean it up a little bit. I'll go in there too and try and make it more readable so that it, you can understand what we're trying to say here. Move things around under different topics, maybe.
Maybe in this document we include the people who are interested.
Sorry?
People who are part of this workshop can be part of this document in some sense.
Yes. The names up there?
Names.
Put your name up there. I'll start. Maybe we put it at the bottom.
Yeah.
4 pages.
It can be a separate, yeah.
Has there been a special issue of co-creativity lately?
That's a good point.
Yeah, I was thinking the same readers, right? Maybe provide a newspaper to a journal session feature.
Has there been one recently somewhere?
Yeah, I was thinking that maybe.
Yeah, we could work towards that. Yeah, I wrote that down as next steps. But if you see any out there that already exist, even if they're a decade old, if we put them up here on this doc, then we can look at those. So I'll go back up to the top. The authors are at the bottom. So you don't want to get distracted by a bazillion things. Okay, well, thank you, everyone. This was really great. I really appreciate it.
Quick announcement, if you're going to go to the Mammal Gallery Mumi concert, or Moon concert tonight, we have MART instructions on how to get there on a piece of paper. Also, there will be a group heading out from the TSRB lobby at 6:20 this evening, if you want to go to the group.